Good evening, and welcome to 25 Standards Every Inspector Should Know. My name is Andy Kushak, and I've been a home inspector for a little over 10 years. Before that, I was in residential and commercial construction. I was actually in commercial construction, and then before that, I was in residential construction. I've always kind of had a passion for construction knowledge, building science, that type of stuff. And the home inspection industry has been really good to me, and so has InterNACHI, and I'm very appreciative to both of them. All right, so let's get started. So 25 standards every inspector should know. Um, So, inspecting a residential building involves looking at many interrelated elements. Inspectors must examine mechanical systems, such as the dwelling's plumbing and electrical, as well as structural components, such as the roof and garage, and several more features in between. This manual provides the fundamentals for inspectors to recognize defects and potential hazards, as well as the proper installation and operation of the most common systems and components in a home. The inspector can then confidently pass on useful information to the homeowner. Standard one, electrical. Oh, let me move my, there we go. Let's move this somewhere else. There. Okay. Uh, Standard one, electrical panels. So we're going to follow by numbers in this slide. So we're going to follow, one through what, 16 on here. So following number one at the top left-hand corner, the service is a general term used to refer to all of the service conductors and equipment for delivering electricity from the utility company to the wiring system of the building served. The service begins at the load end of the service drop or lateral and ends at the enclosure that houses the main disconnecting means. It is typically referred to as the main panel. The first point of disconnect for the conductors from the utility company is the service or main panel. Real quick, before I keep going, I just want to let everybody know that we will take a 10-minute break at the top of the hour, or at the bottom of the hour, I guess. And at that time, during that break, I will review the chat and or the question. Actually, I would prefer if you have questions, if you put it in the Q&A section and not in the chat function. Chat should be to communicate with your peers or ask questions to the InterNACHI team members. But if you have a question about the course, please put it in the Q&A. And then I will review them at the bottom of the hour before we start in on the next hour. All right. All that being said, all right. So that was number one. Number two in the slide. So in the top right-hand corner of the left panel, only one service should be installed for each dwelling or building. A minimum 100 amp service is needed for a single residential dwelling unit. Just a little note on that is that, modern electrical services and modern homes a lot of times are going to call for larger than the 100 amp service. But if you see a 100 amp service, that does not mean that it doesn't meet standards. It might be unusual maybe to see a home on a new construction home or a newer home style that has a 100 amp service, but that does meet minimum standards. So. All right, going down to number three, the service panel is not allowed to be located inside a bathroom, over stairs, or inside a closed closet. Again, I'm sorry, you're going to see lots of homes that are older that are going to have the panels in closets, in laundry rooms above washers and dryers, in cabinets back behind. It is definitely recommended that you recommend to your buyer that after they purchase the home and move in, that they consider upgrading the panel. But if like for instance, in my area, electrical code was not required, was not state required until 1998. So, in a lot of our our homes of older or older homes may have electrical panels that are installed in locations that are not currently acceptable. So, just keep that in mind. Number four, in the top middle up there, refer to the following table when inspecting the service or feeder cable. So the table on the left-hand side, 100 amp service should have a number two aluminum or copper clad aluminum conductor or number four copper conductor. 125 amp service should have 1 aught aluminum or number 2 copper. 150 amp service should have a 2 aught or a number 1 copper conductor, number 2 aught aluminum or number 1 copper conductor. And a 200 amp service should have 4 aught aluminum or 2 aught copper conductors. All right. Number 5, which is going to be in the top right-hand corner. Service entrance conductors must be protected from abrasion by the use of plastic bushings. Bonding bushings and jumpers are required to be used for metal conduits entering the panel enclosure through concentric or eccentric knockouts. It is very common in panels that have been DIY'd or homeowners have tried stuff or electricians, maybe in the country where there's not a lot of oversight, things like that, they might not be using bushings. They might just knock the knockout out and then run the wires directly through. The issue with that is that the sides of the knockout or the panel knockouts can have very sharp edges. And if the electrical cable is in contact with those electrical edges, the when electricity is running through the cable, a vibration exists, and that vibration over time can eventually work through the insulation and come into contact with the electrical panel, which can then energize that panel, making it a safety hazard. So it is really important that your panel bushings, or grommets or something like that is going to be in the panel to protect it from coming into contact with those sharp edges. And in addition, maybe not on the feeder cables, but on your wires coming in through the knockouts should have what do I say? A clamp or some type of a clamp that will prevent the wire from being pulled out of the panel. And that is so when and if you're in an attic and you're walking through the attic, and your foot accidentally catches on a wire and you're might be directly above the panel, that if your foot catches on that wire, it's not going to then pull the wires out of the panel or out of the connector or out of the breaker connection or out of the bus bar or whatever. So there should be some type of a connector clamp and or bushing that will prevent the wire from being pulled off of its connection. Um, where were we at? 5. All right. Number 6. A means of disconnect for the service must be located either outside or inside the dwelling unit near the point of entrance of service conductors. No more than 6 hand movements or no more than 6 circuit breakers may be used to disconnect all service. Typically, a main disconnect switch is required by the local authority. The main disconnect should be clearly marked to identify that it has the service disconnect. Working to number 7 in the bottom right-hand corner of the slide. A grounded conductor is a conductor that is grounded. The grounded conductor is commonly referred to as the neutral conductor. It is usually identified by white or gray insulation. In a panel that has that type of bus bar in the bottom right-hand corner is very common on older panels. And if you're in an older panel, it is also very common to see those neutral wires that are double tapped, whereas more than one wire is installed underneath a lug. It's very common in those panels that it's a fairly new code when you're talking about electrical code that the neutral wires and the ground wires actually be separated and isolated, or yeah, the the neutral and the grounds be separated and the neutrals isolated off the back of the panel in a sub panel inside of a home. But it is common to see those panels that are under multiple lugs. You can have ground wires and neutral wires under the same lug in those older panels. From my experience, generally what I do, because we didn't have a statewide electrical code that required those things to be installed, that I have a standard comment in my report that basically says that any panel older than 30 years old is always going to be recommended for evaluation and upgrade. But I don't make that a requirement, or I don't try to um, portray that as the responsibility of the seller. Unless that panel has been modified or changed, which would then require it to be upgraded to the current standards. If it was never touched, nothing was ever changed on it, nothing was ever updated, and it was installed to the local standard at the time it was installed, then I do not, portray that to be the responsibility of the seller in a transaction to be upgraded. I try to portray that as a recommendation for the buyer to then make those upgrades after they move into the home. Um, so that's number 7. Number 8, up on the left-hand side of that. An ungrounded conductor is a conductor that is not grounded. The ungrounded conductor is commonly referred to as the hot or the line conductor. It is usually identified by black or red insulation, any color other than green, white, or gray. Number 9, a grounding electrode is a device that makes an electrical connection to the earth. A grounding electrode can be rebar in a footer, a copper underground wire pipe within 10 feet of contact with the earth, or a grounding rod. Number 10. Oh, I got a little mixed up on my numbers there. Sorry. Number 10, an equipment grounding conductor is used to ground the electrical equipment. The equipment grounding conductor is commonly referred to as the ground. These conductors are typically identified by green insulation or the conductor is bare. Number 11, a grounding electrode conductor, the GEC, is a conductor used to connect the grounding electrode to the equipment grounding conductor, the grounded conductor, or sorry, I'm gonna start that over. A grounding electrode conductor, the GEC, is a conductor used to connect the grounding electrode to the equipment grounding conductor, the grounded conductor, or both at the service at each building or structure that is supplied by a feeder or branch circuit or at the source of a separately derived system. The GEC is a conductor used for grounding at the service or separate building. The GEC is used to connect to the grounding electrode system. And then number 12, where are we at? Number 12, kind of in the middle panel picture, the bottom. The main bonding jumper must be installed to connect the grounds and the neutral bar and make connection to the enclosure. So there has been, at least in my state, there has been some maybe misunderstandings of where the neutrals and the grounds should be isolated or should be, separated and the neutrals isolated. So we want to make sure that the main disconnect, the main service disconnect, so it's the first means of disconnect after the electrical meter, that panel is ideally the only place that the neutrals and the grounds are bonded together on the same bus bar or bonded with a crossover bar or whatever, where the grounds and the neutrals are basically connected together with by continuity, and that could be through the bus bars attached to the back of the panel, or that could be through the main bonding jumper or whatever. And then the next panel after that, where it comes into maybe on the side of the home or into the panel board inside the garage, the distribution panel or whatever, any panel after the main means of disconnect should then have the neutrals and the grounds separated and the neutrals isolated off the back of the panel. There is, like I said, in my state, there has been some, I don't know, miscommunication or different interpretations of where those separations should be done. So I have one city that will have everything separated at the emergency disconnect on the side of the home. So if the main means of disconnect is in the easement, which is away from the home, then you have an underground feeder that comes to the side of the home, which you have another means of disconnect on the side of the home. And if you were to read the code would specifically state that at that location they should be separated. But like I said, there are different interpretations, and those different interpretations are actually being done by the authority having jurisdiction. So there are different code inspectors from the state, or not from the state, but from the city or from the county, that will not require those locations to be separated and isolated at the second means of disconnect on the outside of the home. So it's up to you. I would just definitely, if you want to start calling those things out, that you call your local AHJ, you call your local code inspector, and you specifically ask them what their interpretation of the code is. And then it's up to you on if on where you want to go from that. So just keep that in mind. So the if well, I'll just repeat myself, but I don't want to do that. So number 12, number 13. All unused holes in the panel should be closed. Again, if a wire has been pulled out of a panel and then the hole is then open, there needs to make sure that everything has been secured. There is no possibility for mice to get up into that panel because that panel is generating heat. It is an attractive. It's attractive to typically to mice or any kind of a rodent, squirrels. Snakes like to get up in there because it's warm. So anywhere that there is potential of a component to be warm can be an attractive location for an animal to make a nest or to get up in there. So that's why we want to make sure all of the holes that were not specifically designed to be open, like in the mounting holes in the bottom of that panel, you can see those are mounting holes down there. And then actually in that middle hole, looks like some wires were ran through, which is also a mounting hole, which is actually incorrectly used as a conduit, as or a through hole for a wire. But that being said, as long as if there are holes in the panel, they have to be intended to be open, as in the mounting holes. But if they are not intended to be open, then they need to be secured shut with a knockout plug or anything to close that hole up like it's supposed to be. All right. Number 14. White insulated conductors that are used as ungrounded conductors or HOTS should be identified at all termination points. So if you read the NEC code, the hot wires are always supposed to be black or red, and then your neutral wires should always be white. There are occasions where the neutral wires will be modified or reconfigured to be used as hot wires. In those instances, there needs to be permanent markings on that wire to ensure that both sides of that wire, both sides of that circuit are identified as being hot. So a lot of times that's going to be black electrical tape. And so you're almost never going to go to the other end of that wire or know where that is terminating. I mean, if you really wanted to dive in deep and really go above and beyond, you could totally do that, but that's your choice. When we're just talking about the panel, white wires that are used on the breaker as a hot need to be permanently identified somehow, which is usually going to be black electrical tape. Number 15. All 15 20 amp 120 volt circuits for dining rooms, living rooms, bedrooms, sunrooms, closets, hallways, or similar areas must be AFCI protected. So with that code, there is a lot of controversy in the among electricians as to the burden that is being put on the cost of home building, on the cost or on the electricians themselves, on installing AFCIs in basically the whole rest of the panel, which can greatly increase the cost of construction. And so while it is still required that it be in those locations, there might be modifications in the future where some of those locations might be taken off because of the quote unquote, what they've told me, the burden of installing those AFCI protected breakers in those locations. So just keep an eye out for those as the code changes every year. NEC changes every year. Other residential code might change every 1 to 2 or 3 years. So we're always keeping an eye on the code changes, and it's also going to change per state and per AHJ. I mean, you could have your city code. Generally, if you have a state code, your state code is the bare minimum, and then your city codes will then modify it and go above and beyond the state code. But generally, 99.9% of the time, they have to at least adhere to the state code and then can modify if you have state code, and then we'll modify, like I said, above and beyond for your local AHJ. And then number 16, each cable should be secured to the panel board enclosure using listed cable connectors. Kind of went over that already. All right, so that is 16. Next slide. Oh, okay, there we go. How are we doing on time here? Oh, we're just in 20 minutes. All right. Standard number one, electrical panel continued. Sheet metal screws are not allowed for grounding connections. Unused openings for circuit breakers should be closed. Correct breaker types should be used for each panel board according to the manufacturer's label. And I'm going to dive in on these here in a second after I read the rest of these. Each circuit should be clearly and specifically identified as to its purpose. No two circuits should be labeled the same. No circuit should be identified in a way that may be subject to change with occupancy. For example, no breaker should be labeled as Ben's bedroom. For people that are moving into the home after the fact, they don't know who Ben is, so it can't be Ben's bedroom or anything very generic. You're going to find generic labels like lighting or outlets or whatever. I mean, it could be living room lighting or living room outlets, something more specific. It shouldn't just be basic. And if you do see something very basic or something too specific like Ben's bedroom, that should be put in your report as recommending for correct labeling or verification of location. All right. Um, Sheet metal screws are not allowed for grounding connections. I think that's pretty straightforward. You just want to make sure that the components that came with the panel are the same components that are used in the panel. And if maybe a specific component has been lost, it needs to be replaced with something the same as. So if you do look into a panel and say, I'm just going to use the main bonding jumper, for instance. That should always, for newer panels, that should be a green screw, something like that. And those locations definitely can't be a sheet metal screw or a self-tapping screw, anything like that. Unused openings for circuit breakers should be closed. I think we already talked about that. Correct breaker type should be used for each panel board according to the manufacturer's label. Um, I think that's pretty straightforward. Now, each circuit, I'm sorry, correct breaker type should be used for each panel board. So in that, uh, so we're going to refer back to this picture on the right-hand side of the slide. So the warning says use only GE type breakers. Use of other circuit breakers voids the warranty, may void the UL listing, and could result in property loss or personal injury. The circuit breakers in this box have been selected to protect the wiring. To avoid damage and loss of protection, do not replace with higher ampere rated breakers. If changes are necessary, call a qualified electrical contractor. Okay, so there is also controversy with this label in that one, we know that different panel manufacturers have bought other manufacturers. So on occasion, you will find different brand breakers in a different brand panel. Um, it is it is very it can be very difficult to figure out, which breakers go in which panel, which ones are allowed, which ones aren't allowed, so on and so forth. I mean, if you read the label, almost every label in every panel is going to state that you can only use the brand breaker in that brand panel. But in reality, when you go into a panel, there is oftentimes you're going to find many different types of breakers in a panel that is not of the same brand. Um, I have talked to several electricians about this, and there is two schools of thought among electricians and with the same respect. Some electricians will say, as long as it's UL listed, it fits in the panel correctly, it's okay to use. Again, some manufacturer of panels bought other brand panels, and they will modify their panels to allow different, their brand breakers under a different brand name to be installed under those brand breakers. And then, or obviously, you're not going to have. Uh, or let me back up. Or you will have different brand breakers in a brand panel that do not fit. And from my experience and talking with many, I've been thrown under the bus both ways. I've been thrown under the bus when I called out different brand breakers in a panel, and the electrician that came out said the inspector doesn't know what they're talking about. And on the second aspect, I've been thrown under the bus by an electrician that said that I caused a safety hazard because I didn't call out different brand breakers in a panel. So it's kind of like you're stuck between a rock and a hard place. So just do whatever you feel is going to be the most safe for your client, and however you want to approach that condition. The things that I have found in my inspection company, in my inspection career, is that because I'm not going to go in and research every brand breaker to determine if it's acceptable and to be by the brand panel manufacturer. I'm not going to go and research which ones can, which ones can't, all that kind of stuff. To me, if the breaker correctly fits in the panel, there's no obvious damage or defect. The breaker is not cockeyed out of the panel, which tells me that brand breaker is not intended for that brand panel. That's when I start to call out my observations, my defects. You do whatever you feel is comfortable, but that's what I do in my inspection process. All right. Number two, well, continuing on, terms to know. So when we're talking about electrical systems, to we want to make sure that we are all using the same terminology as the licensed tradespeople. So in plumbing, you want to use the same terminology that a plumber uses. In electrical, you want to use the same terminology an electrician uses. In HVAC, same thing. Anytime you have a trade-specific industry, you want to be using the same terminology they use, and that's for two reasons. One, you want to make sure that you're not misidentifying something in your report that will end up causing more issues or anything down the road. You don't want to call a grounded conductor an ungrounded conductor, and that can cause problems. The second thing is, when we're talking about it's in the real world, you want to make sure you're using the same terminology. On the second hand of that, you want to make sure that if you are using the correct terminology, so that when your report or your observations get sent to an electrician to go and make those repairs or upgrade the panel or whatever you're recommending, that the electrician doesn't throw you under the bus to the client or to the seller or to the agent and say, well, this inspector doesn't know what they're talking about. They don't even know the right terminology. They don't know what they're talking. And then, that just it puts into the mind of the cell or of everybody involved that it starts to call into question your knowledge, your expertise, and once they start down that road where they start calling into question the knowledge that you have, they will start to pick or nitpick everything in your report. So you want to make sure that you're using the same terminology that the tradespeople use. So, with that said, when we're talking about outlets, an outlet is a point on the electrical wiring system where an electrical current is taken to supply equipment. An outlet can be a wall receptacle, a light fixture, a smoke detector, or an appliance. A wall switch is not considered an outlet since no current is taken at the switch. Current is simply passing through. A device is a part of the electrical system that is intended as its primary function to carry or control electricity but not use electricity, such as a switch or a thermostat. Again, making sure that we're all using the same terminology. We're building up our industry as inspectors and not tearing it down by using incorrect terminology where licensed tradespeople can then use that against us as inspectors. Standard 2, electrical subpanels. All right, subpanels should be supplied with 4 conductors to isolate grounds and neutrals. Kind of already talked a little bit about this stuff, but we're going to go in a little more depth. Though the SER, the servant's entrance cables, are commonly used to supply electricity to subpanels. A typical subpanel is commonly supplied by a 100 amp feeder using number 2 aluminum cable or number 4 copper cable. The equipment grounding bar must be bonded to the subpanel enclosure. A bonding jumper to the neutral bar must not be installed. Again, we talked about the separation of neutrals and isolation of neutrals and the bonding of the ground bus bar and their proper locations. A bonding jumper to the neutral must not be installed. And then number 5, a main breaker is not required for the subpanel if overcurrent protection is provided for the feeder conductors. And then on the slide here, each grounded conductor or neutral wire shall terminate on an individual terminal that is not also used for another conductor, except where the terminal is identified for connection of more than one conductor. And then multiple grounding conductors or grounding wires may be installed under the same terminal if they are the same size, and the maximum number of conductors does not exceed the recommendations of the panel manufacturer. Um, so, so technically, it is okay to double tap ground wires as long as you're using the same gauge of wire under the same lug. Um, and then that is so if you have, so the idea is, and this comes along with this is the issue with double tapping anything really, is that the problem is that if you use two different size wires under the same lug, you get different continuity between each wire as it's connected into that lug. And so you don't want that. You want the same continuity. You want the same, what do I say? The same opportunity for current to flow through the wire, and you don't want a mismatch of current to the wire size. And kind of the same thing goes for your neutrals or your hots. Obviously, you don't want to double tap them again because you want the proper continuity to be able to flow through that wire. And if you double tap a wire, well, one, if you twist them, then that is, you are definitely not going to have the same continuity if the wires are twisted together. If they're not twisted together and they're just side by side parallel to each other, then you might make more contact with one wire than the other wire because the wire can move back and forth inside of that lug space. Then you have the potential to have more contact with one wire than the other, and that can diminish your continuity. The last thing that you want is to have the incorrect continuity of the incorrect wire when it comes down to a safety situation. So if you have a lightning strike, a power surge, or arcing, or whatever, you want to make sure that that the correct continuity is maintained so that the grounding system does what it's supposed to do, the neutral wires do what they're supposed to do, and the hot wires obviously do what you want them to do. And when they don't do what you want them to do, that's when you can get arcing, you can have safety hazards, you can have fire hazards. Um, those are the issues with continuity and double tapping. Next slide. All right, getting out of electrical and getting into the roof. Um, Roofing underlayment. So in areas where there is a history of ice forming along the eaves, causing a backup of water, an ice barrier that consists of at least two layers of underlayment cemented together or a self-adhering polymer-modified bitumen sheet shall be used in lieu of normal underlayment and extend from the lowest edge of all roof surfaces to a point at least 24 inches inside the exterior wall line of the building. Detached structures without conditioned areas are the exception. All underlayment should be layered under the rake flashing and over the drip edge flashing. This configuration sheds water away from the roof structure instead of trapping it. All right. So I have prided myself in my 10 years of inspection industry on being very code centric. And through that, one of the first things that I found whenever I started inspecting to code, which we are not code inspectors. We want to make that very clear. We are not code inspectors, but it is extremely important that we know code because our standards are based on code. Also, we want to talk about code in that code allows us to identify potential defects or potential damage that can occur from something not installed to code. For instance, this is a good example. When the underlayment is incorrectly lapped over the drip edge flashing, it is a long-term problem for a client. It's not a short-term thing. So, a lot of times that's why builders can get away with doing things not to code, is because by the time their liability ends, they are well outside of their warranty period, and then it becomes the responsibility of the homeowner that if any damage is ensued after that fact, then they're the ones that are going to have to take care of it. Um, so when you have underlayment, and I'll tell you, I've talked to many roofers about this, and I understand why they don't layer it correctly. It's one is that the roofing industry is there's there's some misconceptions out there that that when you hire a roofing company, and in my area we have hundreds of roofing companies, and I'm sure you do too in your area. But when it comes down to the roofing crews, there's only a fraction of the roofing crews that actually do the work versus the roofing companies that are out there selling roofs. And so most roofing companies subcontract out to the same roofing crews. So that's where you can get a lot of issues or a lot of the same observations from multiple different builders because they're all using the same roofing crews. So um, and those same roofing crews, a lot of times, the roofing crew that's going to come and replace your roof, if you have hail damage or whatever, is the same roofing crew that are building new construction houses. So the things that they do in new construction to allow for speed of installation oftentimes is what causes problems with roof deterioration over a long period of time. So one of those things is they will put the underlayment down on the roof, and then they put the drip. So, here's your roof. They put the underlayment on top of the roof decking, and then because on new construction they're trying to do three, four, five houses at a time and roof them all in sequence. So they will prep them all, and then because they're prepping them all, they want to make sure that there is no wind that's going to take off that underlayment in between them being able to put the shingles actually on. So, in order to keep the underlayment on the roof and prevent the wind from taking it off, at the drip edge, they put the drip edge over the underlayment to keep the underlayment attached to the roof. That is wrong, right? So the underlayment is supposed to be over the drip edge over the drip edge at the eave of the roof. We want the underlayment over the drip edge at the eave of the roof because if water gets underneath the shingles and it rides that underlayment all the way down to the edge, we want it to then drip off of the underlayment and then drip off. Maybe it hits the drip edge and then it goes off into the gutter or off of the home. For speed, these guys are putting the drip edge over it, and so when that water is riding underneath the shingles and on top of the drip edge, it goes in between the drip edge flashing and the underlayment, and it gets trapped at the edge of the roof because there's no airflow in that location. If it's continually raining, you have a very rainy season or whatever, that area is not allowed to dry out, and that roof decking will start to rot from the edge of the roof up. Again, that's a long-term thing. So a new construction home, it might take 5, 8, 10 years for there to be deterioration observed. And it might not even take, it might take longer than that. It might take shorter than that. It all depends. But on average, you're looking at 10 or 15 years, maybe never, or maybe sooner. Um, but we don't want our clients to have to carry the weight of that repair because it was originally done incorrectly. But so for 10 years, I have been calling that out. In every one of my reports now, I have since switched the way that I do that. Um, but I only call it out on new construction anymore. For me, I don't consider it the responsibility of the seller to make those modifications if their roof is 5, 10, 15 years old, that they then have, I then call out the underlayment being incorrectly overlapped. It causes a lot of confusion, a lot of angst, a lot of friction in the transaction. So for me personally, I stopped calling that out on existing roofs. But on a new construction roof, I call it out every time because I want the seller or the buyer, my client, to have that option to ask the builder to do it correctly. So that's my personal preference, but it's up to you on how you guys want to handle that. Um, all right, roofing underlayment. I'm going to be very honest with you. We don't really deal with ice damming in my area. So I'm not 100%. I mean, I've read the code. I see the diagrams. I know what it means and why it's there. But I don't have a lot of real world experience with ice damming. So I'm not going to dive in too deep on that one. But um, if it were up to me on my roof, I would ice and water shield the whole thing. But that's my personal preference. So let's see. Next, where are we at on time here? All right, about 10 more minutes and then I'll take questions. Standard number 4, glazing. Many areas are hazardous because of their frequent impact by the building's occupants. Glazing located indoors is of particular concern because of the increased probability of accidental impact while operating the doors. Excuse me. A person may often push against the glazed portion of a door in order to operate it. A large piece of glass located along a travel path where no barrier is provided is a dangerous area. Glazing is a glass or other transparent or translucent glazing material. The glazing area is the interior surface area of all glazed fenestration, including the sash, curb, and framing elements. For example, the 2018 IRC R303.1 says that habitable rooms must have an aggregate glazing area of not less than 8% of the floor area. Fenestration refers to windows, vertical fenestration, skylights, and sloped glazing. Fenestration includes products with glass or other transparent or translucent glazing material. Vertical fenestration refers to windows that are fixed or movable, opaque doors, glazed block, and combination opaque and glazed doors installed in a wall at less than 15 degrees from vertical. For example, a double hung window is a vertical fenestration. Sloped glazing refers to glass or other transparent or translucent glazing material installed at a slope of 15 degrees or more from the vertical. For example, a skylight is a factory assembled sloped glazed fenestration unit that has one panel of glazing. In general, each panel of glazing located in specific hazardous locations defined in the 2018 IRC Section 308 must be of the safety glazing type. The safety glazing must have a manufacturer's designation or label that is visible and permanent, which identifies the type of glass and the safety glazing standard with which it complies. For the purpose of glazing, the following areas are considered specific hazardous location. Swinging doors, except jalousies, which are the small the small pieces of glass that open like an awning. Yeah. Glazing in fixed and sliding doors, glazing in sliding and bifold closet doors, glazing in storm doors, glazing in all unframed swinging doors, glazing in doors and enclosures for hot tubs, whirlpools, saunas, steam rooms, bathtubs, and showers, and glazing in any part of a building wall enclosing these compartments where the bottom exposed edge of the glazing is less than 60 inches measured vertically above any standing or walking surface. Be particularly careful in checking windows inside bath and shower assemblies. Glazing in an individual fixed or operable panel adjacent to a door where the nearest vertical edge is within 24-inch arc of the door in a closed position and whose bottom edge is less than 60 inches above the floor or walking surface. Glazing in a panel other than those locations described in items 6 and 7 that meets all of the following conditions. Exposed area of an individual pane is larger than 9 square feet. The bottom edge is less than 18 inches. The top edge more than 36 inches above the floor, and one or more walking surfaces within 36 inches horizontally of the glazing. All glazing in railings need to be protected. Glazing in walls around swimming pools, hot tubs, and spas where the bottom edge of the glazing is less than 60 inches above a walking surface, and within 60 inches horizontally of the water's edge. Glazing next to stairways, landings, or ramps within 36 inches of a walking surface if the exposed surface of the glass is less than 60 inches above the adjacent walking surface. Glazing next to stairways within 60 inches, 60 horizontal inches of the bottom tread in any direction if the exposed surface of the glass is less than 60 inches above the nose of the tread. All right, there's a lot there. So, and then just FYI, glass block is considered masonry and does not have to adhere to the glazing requirements or to the glazing requirements. There are products and applications that are exempt from the requirements for hazardous locations, including small openings and doors through which a 3-inch diameter sphere cannot pass, and specific decorative pieces such as leaded glass. All right, there's a lot there. If you wanted to start calling out glazing, I would highly recommend reading the code, finding some diagrams that will show you the locations of the required glazing protection. The only thing the only time I've really when I'm not doing a phase inspection where I'm specifically calling out code requirements, if I'm just doing a new construction home inspection or an existing home inspection, your standard home inspection, uh, the only time I've really found issues with glazing is when a window has been replaced. If a window has been replaced, sometimes the windows that's been replaced, if it was a DIY job, maybe the homeowner went and just bought a window from Lowe's or Home Depot or whatever, and then replaced the windows themselves, but did not replace it from with safety glass. Or in new construction, I've seen where, and this was kind of back when windows were really hard to get after COVID, when I think windows were on order like 8 months or something like that. And so what a lot of contractors did was because they couldn't get a safety glazed window, if one had broken during construction, they would take a non-safety glazed window and install it kind of as a temporary fix so that they could get the home finish dried in or whatever, and then it gets forgotten about. And then so those instances are when I have called out the need for safety glazing. So if you're looking at a window and you suspect it to not be a safety glazed window, and it should be, make sure you're being 100%, 100% that that window should be safety glazed, and look for the etching in the bottom corners of the window. The bottom corners, the code for safety glazing requires that the window be permanently marked as a safety glazed window or a tempered window. So look for that marking. There should be some type of etching. Usually it's etching. There might be a stamp of some kind that has ink that cannot be removed or won't fade in the sun. All I've ever really seen is the etching type. So look for that etching. And then if you can't find that etching, it's up to you if you want to call that out and how big of a deal you want to make it. But just know that we want to protect our clients. We want to do what's best for them and do whatever you feel is right. All right. All right, 5 more minutes and we'll take a break. Let's see if we can get into the standard. So garage firewall. All right, so following along 1 to 4, or well, 1 through 6, honestly. So number 1, the door between an attached garage and a dwelling unit should be a solid wood door, not less than 1 3/8 inches thick, a solid or honeycomb steel door, not less than 1 3/8 inches thick, or a labeled and 20-minute fire rated door. So in that, we know that older homes a lot of times have hollow core doors going from the garage into the home. Um, you know, the issue with that is that it has been shown that most house fires start in garages, which is why the firewalls in garages, the fire door from the garage is very important to maintaining the intended safety of your client. Now, again, it's up to you on how you describe that to your client. If it's an older home that did not have those requirements, I just recommend it to my client that after moving in, they update the door as desired. Obviously if it's a new construction or a home built within in the recent years, then I would maybe put that responsibility or put that recommendation to have it repaired or replaced by a licensed contractor. So that's kind of the difference between my how I kind of differentiate who, in my professional opinion, I feel is responsible for the change of components. If if the door was replaced and it wasn't replaced with the correct components, and it should have been replaced with the correct components, then I don't state that it has to be replaced by the seller. I make the comment that it needs to be repaired and replaced, and let the client and the agent determine how important that is to them and how they want to proceed going forward. Versus if the unit was installed as intended when it was originally installed, no modifications have been made, everything is the way it was, the way everything was the way it was whenever it was or it met standards when it was originally installed, then I recommend, hey, I don't put it in the summary. I don't put it in the summary of the report, but I do put it in the report and recommend the client to upgrade as desired. That's kind of how I pick and choose my words very carefully and try to uh, let the client know, you know, this was normal when it was installed. It's not normal now. You upgrade it as you desire. All right. Number two, although drywall or other approved material can provide a firewall separation at the walls and the ceilings between the garage and the dwelling unit, openings that penetrate the separation should be appropriately protected. So when it comes to drywall in a garage, oh, let me see here. I think we are. Oh, well, I'll speak on this and then we'll take a break. So the fire rating for drywall comes from the thickness of the drywall. And so when you penetrate, when you have the two joints of drywall, they are tapered at the ends so that when you meet the ends together, you can mud and tape that seam and then fill the seam up with drywall knives and make that a smooth transition so that the thickness of the drywall is maintained throughout. So that's where the fire rating comes in drywall. And so a garage has a specific firewall rating because of the thickness of the drywall. And if your screws are countersunk, your seams are not mudded and taped correctly, your penetrations, how the drywall was installed, which we'll get into that in a little bit. If the thickness of the drywall is not maintained, then the firewall rating is compromised. Not to say that there's not a firewall still, but the intended firewall rating is compromised. You're going to have less protection at the countersunk screw holes and at the non-mudded and taped or non-correctly mudded and taped seams. All right. With that said, we're going to take a break, and I am going to answer some questions here. All right, so question one, AFCI, is that for older panels as well? From Nicholas Basil. No. So AFCI is only required if the circuit has been modified or changed on an older panel. If the breaker if the breaker has been changed out for whatever reason, maybe the breaker went bad, maybe there was arcing or damage, or the breaker is just old and it was loose in its connection. If that breaker is replaced and if it was replaced today and it's in a location that now requires AFCI protection, then yes, it has to be upgraded to AFCI protection. Let's see. Number two, anonymous attendee. If a main panel has four aluminum conductors entering the panel, including one connected to the ground bus bar, do you need a ground screw? All right, so always need a screw. If a main panel has four aluminum conductors entering the panel, including one connected to the ground bus bar, do you need a ground screw? It depends if that's the main panel. If it's the main panel, the first means of disconnect, um, then both the neutrals and the grounds should be bonded together and bonded to the back of the panel with a ground screw or a main bonding jumper. Anonymous, Minimal labels, should that be considered defective repair or maintenance? I would agree with Robert, defect. Um, because, whoever's living in the home know, they should know where those circuits are. They a lot of times, maybe it's not labeled right, but they know that that breaker goes to that circuit in that bedroom. But when somebody new moves in, they don't know those things. They don't have the history of that house. Um, and to put the burden on the buyer to correctly label the circuits is should not be done. It should be the responsibility of the homeowner or the builder to correctly label the panel so that and not so a buyer shouldn't have to hire an electrician to come in and identify the circuits. It should be done correctly in the first place. Stephen Caddy, service panel that has two obvious service grounding wires. One wire properly connects to the public water copper pipe coming out of the concrete floor. Second wire goes through the joist header outside. Outside, it disappeared under the landscaping. Do I need to call out the ground wire that I cannot confirm is properly grounded outside? No. The ground wires should actually be going into the ground. I mean, if you have a, ground rod or something on the outside of the home, that ground rod should actually be at or below ground level because you don't want a lawnmower, weed eater, or whatever to drive over it and then to do damage, do damage to your lawnmower, your weed eater, or whatever. So for me, if a ground wire goes into a conduit or the ground wire goes into the ground, what I've done, and I've seen this in the past, is one, you want to make sure, one, that it's not carrying any voltage. So use your non-contact voltage tester, test it to make sure it's not carrying any current. And then when it's not carrying any current, I will run my hand and follow the wire into the ground and then try to, and not severely pull the wire up, but I give the wire a tug to make sure it's connected to something. I have seen in the past where the ground wire has just been shoved into the ground and indicating a false or fake ground wire. That would be my recommendation. I do not call it out as a defect. It's, you know, if you wanted to make sure that you are fully protecting yourself, you could state that the bonding connection to the grounding electrode could not be verified. But because you're going to find that in so many applications, you would be putting that on most of your reports. So it's up to you on if you want to put that in the report, but because it's standard that the wire goes into the ground and the actual connection is not visible, then I personally do not do those things, but I do give a tug on that wire. If I can, if I do see the wire, I do give a tug on it to make sure it's just not sticking into the ground. Does this webinar apply to California code standards? So the standards that we are referring to are national standards. It is not specific to any state. So it depends on California, honestly. Your California standards might vary greatly because your state standards do not have to follow national standards. So when standards are created, the national standard, generally every state that has every state that has standards uses the national standard as a base and then will then modify it to their specific states. California being so big, I'm sure many of your locations have changes in those code requirements. So I would just refer to your local AHJ, so there might be modifications from what we're talking about here because here we are talking about national standards, but it might be different for California. Do you recommend safety film as an alternative to tempered glass? There is only, I do not. I would recommend tempered glass. If the code calls for tempered glass, it needs to be tempered glass. If it calls for heat treated glass, it needs to be heat treated glass. If you don't have, standards have changed a lot. So, for instance, like a single pane window in a 1905, a 1900s house, 1905 house, window that is on a landing between two floors is a lot of times it's single pane. It's not tempered. It's obviously within 60 inches of the floor. It's wider than 9 square feet, and it honestly it should be then protected, but it's for a homeowner. If I was doing a cellar inspection or I was doing an investigation for a homeowner or whatever, then I would recommend them to upgrade it to, if you wanted to use safety film, add the safety film to it because any protection is better than non-protected at all. But when it comes to an actual home inspection, I would recommend it to be protected with standard code required stuff, code required safety glass or tempered glass, whatever. Is in commercial, the frame jam has to be fire rated as well. Is that true for the garage? No, it is not true. In residential, you do not have to have fire rated frame or jam, just the door. Should have a self closer as well. So again, that change, yes, every garage door should have a self closer. It is actually very easy to install. Um, I want to say spring hinged jams to allow for a door to self-close. But states like my state, I'm in Arkansas, we do not require garage doors to be self-closing or self-latching. Now, we do have builders that are nationwide builders that are installing self-closing doors and spring hinge doors or whatever. And so in some instances, we do have builders that are installing them, but for my state, we are not yet requiring it. But yes, it should have a self-closer if you want to go to the maximum safety standard. Garage attic non-heated, it is required to be insulated? No. Garage attics is not part, so only the walls and the ceilings around the living space are required to be insulated. A garage ceiling is not required to be insulated. Do you use AFCI tester to ensure the circuit is working properly? How do you decide when and when not to test them? So for me, I don't use an AFCI tester. All I do is because we are not, again, this is, it's going to probably vary per state. Our state code does not require AFCI outlets, or all of our AFCI protection is in the breakers inside of a panel board. So when I'm testing for AFCI, all I'm doing is pressing the test button on the breaker themselves. So that's how I test for AFCI. But like I said, we are not installing, I don't think I've ever seen an AFCI outlet installed. Okay, I just wanted to reiterate one time real quick. Um, when we're talking about safety and current safety standards versus prior safety standards, I want to be very clear. I always call out newer safety standards in my reports, but I differentiate in my report, and where I put it will dictate how a realtor and a client will use that information and understand that information. So just want to be very clear that safety standards I'm always going to put in the report, but how I put them in the report changes very depending on my knowledge, my experience, and sometimes even my client and the realtor. If I have a builder that is one of my clients, or I have a code, a local code inspector that's one of my clients, that might change where I put items and how I word items in my report. I know some inspectors are black and white. It is the way it is. It goes in the report every time the same way. Me and myself, I change sometimes the way that I word things and where I put them in the report. For instance, for me, a summary is used for the client and the realtor to use in negotiating tactics. So when I consider that when I'm talking about things, if like for instance, when we're talking about drywall in a garage, a existing home that has drywall defects on the living side of the home, or yeah, so if it was originally installed and there was no comment or code or there was no standard from which it was, then I might not put it in the summary unless I feel like it could cause like a first-time home buyer. If there's a huge wall or a huge hole in a wall on the living side of the home, I'm going to, put that in the summary as recommend for repair replace to maintain the firewall safety between the garage and the house. But had that be for a drywall contractor or a builder or somebody, and they come and tell me like, I'm only worried about the big ticket items like the HVAC and the structure and stuff, then I might not put a hole in the drywall in the garage in the summary. So it's again, it's your personal preference. Summaries are not required by any SOP, and so it's up to you on how you use that summary. And obviously, it's up to you on how you word your comments. Um, you know, Nobody wants to be considered. Well, some people want to be considered a deal killer. I personally don't want to be considered a deal killer, so I modify the way that I word things. To my client, to the house, to the situation. So that's on me. It's up to you on how you want to build your business and your inspection reports in your career. So, okay, off my high horse there. All right, so now we are self-closing door. So we talked about the self-closing door. That was actually that was the next thing. So I'll just read it so we can get through it. So the type of door construction or the fire rating of the door is important. In many jurisdictions, a self-closing device on the door may be required. The entire door assembly may have to be fire rated. Um, One thing I will say about that. So if a self-closing hinge is installed on the door but does not swing closed or self latch, I do call that out as an installation defect. So if something is installed and and supposed to be there for a specific purpose but doesn't operate like as intended, then I consider that a defect. But because in my state self-closing hinges are not required, if it's not present, I don't consider it a defect. But if it's installed and not working like it's supposed to, I do consider it a defect. All right. Number four, where an air duct passes through the drywall gypsum board located on the garage side of the firewall separation, the duct material should be a minimum of number 26 gauge sheet material. There should not be any openings in the ductwork within the garage area. So obviously, number four, there's two reasons why you don't want ductwork installed inside of a garage that then is distributed from the interior of the home. And that is for fire safety. You want to make sure that because a garage is the most common location to have a house fire started, you want to make sure that fire and smoke do not quickly pass in through the duct and into the home, and into the HVAC system, and it allows the fire and the smoke to quickly spread. So we don't want that because obviously our garage should be fire rated. And two, you also have so fire and smoke safety. You also have a lot of times you have gas, you have combustible components, you have volatile materials in a garage, and you don't want those. You don't want those fumes and all of that stuff to get pulled or sucked into the attic, or to be able to easily pass into the house or the HVAC system and lower the air quality inside the home itself. And number five, without exception, all electrical receptacles in garages must be GFCI protected. Again, if you wanted to look up the exact date and time or year that the code was enacted in your location for GFCI protection, and differentiate between when it was not required to be GFCI protected to now it is required to be GFCI protected. Again, it's up to you. For me, in that instance, I would recommend the outlets, and basically any place GFCI is now recommended to be installed, I'm always going to recommend that to be upgraded to GFCI. But whether I put it in the summary or not will dictate on how old the house is, when the outlet was installed. If the outlet was replaced and was replaced recently, then it definitely should have been upgraded to GFCI. So that's how I differentiate. Number six, a direct opening between an attached garage and a sleeping room is not permitted. That opening is hazardous. So many times, remodeled homes are notorious for this, right? So you get a remodeled house that they decided to modify, move things around so that they get more square footage, so that they could increase their price per square foot or increase the bedroom count. And what used to be the living room or what used to be a laundry room that was attached to the garage is now a bedroom. So in those instances, definitely recommend to that client that things change, things be modified, the bedroom not be considered a bedroom, however that be done. That's up to the realtor and the client. It's only it's only up to you to make the statement and then let the client and the realtor decide what to do with that information after that. Um, all right. Okay, that's next slide. Garage drywall. So again, we're kind of in the same area of fire rating for the garage drywall. It is common for a fire to start in an attached garage. The fire may grow unnoticed by the occupants and become a significant hazard. Therefore, a minimum amount of fire protection is needed. This standard requires a minimum level of fire protection from the garage to the dwelling unit. It allows the occupants to time to escape in case of a fire. The separation also restricts the spread of fire from the garage to the dwelling unit. Until the fire can be controlled and extinguished. There should be at least half-inch drywall applied to the garage side to separate the garage from the residence and its attic space. So that's the key right there. Garages located below a habitable room should be separated by at least 5/8 inch type X drywall, gypsum board or equivalent. All right, so there's two ways that garages are usually attached to a home. One is you have the garage is completely contained within itself, where you have drywall on the ceiling and on the walls. The other is where the ceiling structure in the drywall is exposed, and but if the ceiling if the ceiling structure is exposed in a garage, then you must maintain that fire rating all the way up to the roof and have that fire rated barrier between the garage and the garage roof structure and the house and the attic structure. Um, I just did an inspection a couple weeks ago where we had this beautiful lake home. It was, I don't know, probably 3,000 square feet. It had not a garage, but a shop integrated into the basement. And that shop had no separation between the shop and the master bedroom above it, or the primary bedroom above it. So I did, and it was a seller's inspection. So, in a seller's inspection or a pre-listing inspection, it's in my opinion, it's my job to call out all the potential observations that any buyer's inspector might make, and to be able to quantify that to the seller so that they are prepared to answer those questions by a seller or by a seller, or I'm sorry, by a buyer or by a buyer's agent. And so in that instance, I told him, the garage shop is not considered a garage, or I'm sorry, the basement shop is not considered a garage, but you still are more likely to have you're still more likely to have a fire start in the shop, because you're still storing gas, you're still storing combustible materials, paints, all those types of things. And with the primary bedroom directly above it, you have a potential for a serious fire hazard. So I just put it in my report. I told him, at the time your home was built, one, he was in the country, and two, out by the lake where there was no real standard, and the home was built way before we had code, applicable state code. And so I just told him, I was like, look, you have a shop down here, you've got, and your shop was full of tools and paints and thinners and gas and all kinds of stuff, and you have a high likelihood of having a fire in this location. And to maintain the safety of the home, it would be highly advisable that this be have a fire rating ceiling on from fire rated ceiling and walls. Now obviously I think that is he he was like, okay, I understand where you're coming from. I understand that maybe the buyer and the buyer's agent are going to see that. They're going to understand it. But the fact was is that it was allowed whenever the home was built. It would not be allowed in today's standard, but I did my due diligence. I informed him that this might come up and you might be asked for this because, as we all know, well, I don't know where you guys are, but in my area, we are in a buyer's market. So a lot of buyers have feel like they have a lot of negotiating power and might be asking for things that they don't normally or that they wouldn't ask for in a seller's market where they have to take what they can get versus now they have a lot of control over the transaction and they can make a lot of requests on their sellers. So keep that in mind. All right. Standard 7, emergency egress. Um, Again, folks, we will answer questions at the bottom of the hour. So just keep your questions or put them in the Q&A, and I will answer them 10 minutes before the hour is up. So um, basements and every sleeping room should have at least one operable emergency escape and rescue opening that opens directly into a public street, public alley, yard, or court. Where basements have one or more sleeping rooms, an emergency egress and rescue opening should be installed for each sleeping room, but is not required in adjoining areas of the basement. Because many deaths and injuries are caused by occupants being asleep at the time of a fire, the standard requires that basements and all sleeping rooms have doors or windows that can be used for rescue or escape in an emergency. During a fire, the normal means of escape will most likely be blocked. The sill height of an emergency escape and rescue opening should not be more than 44 inches above the floor. If the emergency escape and rescue opening has a sill height below ground level, a window well should be provided. The window well should have a horizontal area of at least 9 square feet with a minimum horizontal projection and width of 36 inches, with the exception of a ladder encroachment into the required dimension. Ladders do not count inside the width of 36 inches, as long as the ladder is properly installed. If an emergency escape window is located under a porch or deck, the porch or deck should allow the window to be fully open, and the escape path should be at least be 3 feet in height and 3 feet in width. Which, if you think about it, 3 feet in height and 3 feet in width is not that much. So if you go below the 3 feet in height, 3 feet in width, then you could have potential egress issues. Where we see this the most common in my area. So in my area, we have a very high water table. We have very clay ground. I'm in Northwest Arkansas, and we don't have basements for the most part. We have a few, but they are very far and few between. So what we do have a lot of is hills and mountains, and so we have a lot of walkout basements. And so there are a lot of rooms. Again, a lot of our homes were built, pre state code requirements. And so we have a lot of homes that have a walkout basement that have bedrooms, but do not. But all they have is a small square skylight or light open at the top of the wall, and no emergency egress. So and I'm not a realtor. I don't pretend to be a realtor, but I do know that there are some instances where if you don't have a second, if you don't have an emergency egress besides your main door, then that room cannot be considered in real estate as a bedroom. And I don't know something about closets too, but I don't really get into that. Just talking about emergency egress. So, it is it would be it would be very important for you to be able to identify in a home that does not have a secondary egress or emergency egress, that you make the client or you make your client aware that there is not an emergency egress for this specific room. Now it's up to the realtor and it's up to the client on how important that is to them and what they're going to do about it. But you just do what you're supposed to do and call out that there is no emergency egress for this basement window, and then leave it at that. Obviously, the 44-inch max from the bottom of a clear opening. You don't want to have to use a ladder or have any type of device that will require you that could potentially be moved out of the room in order for you to gain access to the emergency egress. So that's why 44-inch maximum is the maximum required. You don't want to have a step stool, stairs, or ladder to get up into your emergency egress opening. Um, Now, when you do have a window well, it is very common because window wells, well, one, you want to make sure that if you do have a window well, that if you don't have some type of a cover over it, that there is some type of a drain below it, or that water does not pool or fill up the window well. So you want to make sure that there is some way for the water to drain out. Um, and then if you do have some type of a grate or covering or bulkhead or something over the top of it, that it can be fully opened so that so that there's no obstruction from quickly making an emergency escape out of the home. Um, I was going to make another point on that. What was it? I don't know. Maybe I'll come back to it here. Okay. Let's see. All right, drainage. So, proper drainage of the building site is important in preventing wet basements, damp crawl spaces, erosion, and possible failure of the foundation. Proper drainage should include adequate slope of the ground directed toward drainage devices that are capable of carrying surface water runoff. Gutters and downspouts should direct roof water to appropriate drainage areas. Surface water should be diverted to a storm sewer system or other drainage points. Building sites should be graded so as to drain surface water away from the foundation. The ground surface should slope a minimum of 6 inches within the first 10 feet. Drainage systems or swales are effective methods for controlling surface water, especially in areas where attaining the minimum grade is not possible. All right. So if you've done any new construction inspections, or if you're a newer inspector, just know that one of the things that is least likely to be called out by a code inspector or by your AHJ is correct grading. Most of the I don't think we have a single code official or a single code official, or I mean we do have some builders that take care of grading, but I don't think we have a single code official in my area that calls out negative grading or incorrectly sloped grade. So that is something that is super important for us as home inspectors to identify and to call out as need of correction, especially if you have a crawl space or basement. Um, and not only if you have a crawl space or a basement, but if you don't have gutters in your area. So, like my state, gutters are not required in my state. So we have a lot of homes that don't have gutters on them. So when you have a home that doesn't have gutters and you have negative grading and you have a basement or a crawl space, more likely a crawl space in my area, then a lot of times you are going to find flooding or water intrusion in the crawl space and basement. Um, Also, when you're doing an inspection, the way that we're building subdivisions now is, well, here, I'll tell a quick story. So there was uh, back in the first housing bubble, which was what, 2007, 2009, something like that. There was a huge development that was developed, and then the developer went bankrupt when the bubble burst. So that developed land sat vacant or undisturbed for, I don't know, let's see, 2007, for about 10 to 12 years. It's out abandoned. Uh, but around that development, there was all kinds of other construction going on. So um, as hard surfaces were being installed on these other subdivisions, it was changing the way that the groundwater was being that was running to its original locations, right? So you have this big field. It was originally approved and had civil engineers that designed the 100-year floodplain and developed all of that. Well, then all this other subdivisions went in around it, and then it finally got bought up by another developer. The city did not require the developed land to be recertified for the 100-year floodplain and the changes in water diversion and water drainage. So the development got built out, and it's really hard for me to think that issues were not immediately visible when the new builder came in and started building on that land, because I was called in after the development was done. They had sold. There was this group of four houses on the corner lot where it backed up to what was still a field at that time, which had a pond on it. The pond was only probably less than 100 yards away. As the development that went around that farmland changed on the backsides, the fronts, the road changed, the way water drainage changed between all of those things. Well, then every time it rained, the water was being had the pond had taken a lot of that overflow water that was not originally there when they first developed the subdivision I'm talking about, and that pond ended up overflowing every time it rained. Well, all of that water ended up coming down into four houses on that new subdivision, and it flooded four houses every time it rained. Well, when the client bought the home, they didn't get a home inspection. I came in as an investigator after the fact, um, but I had to determine, I had to do historical rain counts and historical rain events and prove that every time that it rained, those four lots flooded. Um, so, the flooring was done. After the 100-year flood plan was changed because of all the other changes that had occurred, and because the city did not make them redevelop it, then those four houses were affected. So the builder blamed the city for not making them required to redo the civil engineering on it, and so it was a lot of he said, she said, a lot of finger pointing going around. Eventually, the builder agreed to sell or to move the client to a home on the other side of the subdivision, and while they modified the drainage plan for that caused those four houses to be flooded every time. So everybody was happy in the end, but it took a lot of negotiating. It took a lot of investigation. We called in civil engineers that showed that the drainage had changed over time. So that being said, even new construction, you cannot 100% guarantee that the drainage was done correctly, or it was done, or maybe had modified or changed over the years. Uh, so just pay special attention to the ground, how muddy it is. What's a really good indicator is if you open up water meters and the water meters have water in them, and that it hasn't rained for, 2, 3 weeks or a month, and there's still water in there, then you know that your water table is very high. And then pay special attention to the yard. If modifications have been done to a person's yard, maybe you have dry creek beds where somebody had water drainage issues, and so they put in dry creek beds, or they put in rock next to the home. And a lot of times, the only reason why you put rock next to a home is because you have water drainage issues. Additionally, because we have these subdivisions that are built on a quarter acre of land or less, and they're pushing these houses together, if you go up and you have a really small side yard, only 4 feet wide or whatever, and you have a lot of rock down there, then that could mean that they have water drainage issues. If you do see those issues, and it's not been raining, and there's not clear evidence of it, it's up to you if you wanted to say, hey, there's evidence here that there might be water drainage issues here. Maybe they don't have positive grading away from the home, or or maybe you do have positive grading away from the home, but because the lots are so small, all the water is draining along the fence line, and now the fence line stays consistently wet because so the neighbor is also draining water away from the home, and now the only place that can go is where the swale is, and the swale is along the fence line because that's the property line. So just keep an eye on those things, because your fence posts will deteriorate much faster in those locations. Now, we're not required to inspect fences, but you might make the decision to inspect fences. And if you do inspect fences and you have a consistently wet property line, then you can point that out to the client and recommend, hey, you might need to install yard drains, or you might need to install or hire a landscaper to, landscape the water and make sure that the water is, going out to daylight, or put in a French drain or something like that. Drainage is a huge thing, especially in new developments. A lot of times, you might not have drainage issues on existing homes because they've already went through all of this stuff. But you can see the picture here on the top right-hand side. Negative draining creates water and structural problems. And a lot of times when you have a hill that you have a uphill slope on the uphill side, over time, as the water drains down that slope, it's carrying sediment with it, it's carrying rocks with it, and eventually, if you did have a swale at the bottom of that hill that was directing water away from that home, that swale might fill with debris over the course of over the period of years, and now instead of having a swale, you have a negative slope all the way to the home. So again, if water is allowed to continually drain next to a home, if you have a slab, the earth below the footer could turn to mud and it can settle, and then that can cause settlement of the structure, which can cause settlement of the side of the home, so on and so forth. So um, just pay special attention to your grading, your water drainage issues. Look for evidence of modifications that people have made over the years, and determine maybe there's nothing wrong with it. Maybe everything has been upgraded, has been changed, and everything is good. Then maybe point that out to the client. Hey, all of these things are good now. There might have been issues in the past, but this looks like a good update or a good modification. But definitely keep a monitor on it, keep an eye on it. And if anything starts to change, where you start to notice water against the home, you start to notice water in the crawl space, then additional modifications need to be made. All right. Standard 9, anchorage. To prevent walls and floors from shifting under lateral loads. All right, we've got 20 more minutes and we'll go to questions and take a break. Um, to prevent walls and floors, from shifting under lateral loads, anchorage to the supporting foundation is required. Wood sill plates and wood walls supported directly on continuous foundations must be anchored to the foundation. Anchor bolts can be used as well as foundation straps if installed in accordance with the manufacturer's instruction. Look for anchorage. Bolts must be at least a half inch in diameter. So generally, if you have concrete, this is the J bolt that you're only going to see this part coming out of the sill plate. But generally, when you have a foundation bolt, it's a J bolt that looks like this, and you have a washer. So whenever you have concrete or CMU block and your cells are filled, a lot of times they'll pour the concrete, and then to ensure that they're placing the bolts correctly, then they put the bolt into the concrete and then let it all harden around. And the J at the end of the J bolt is what's keeping the bolt from being pulled out of the foundation wall. Every foundation bolt should have a nut and a washer. Um, this is what, 7 inches tall. You're not going to know if this is 7 inches tall, but just ensuring that you have a bolt, it is tight. A lot of times you're going to find bolts that are very loose, and making sure that every anchor location has a washer on it. That's for J bolts. Foundation straps are different, obviously. Foundation straps, if you have a strap, a lot of times that's embedded into the concrete. Um, I don't know how to do this. So this is the embedded into the concrete, and then this is your sill plate, and then the strap wraps around it like that. And making sure that all of the mounting holes on the strap are filled with mounting hardware. All right, so bolts must not be space greater than 6 feet on center, so you should have a bolt every 6 feet. So that's a pretty easy identifier if you're in a crawl space or in a basement. Should be, sometimes insulation is covering the sill plate, or actually, honestly, insulation should be covering the sill plate. So if you want to check for bolts, because we're not required to move insulation, um, you know, if you wanted to check for them, you could do a spot check if you wanted to. Just, pull them back, take a look, make sure they're tight, and then continue down the wall, check to make sure that they're 6 feet apart or no more than 6 feet apart. then that's up to you if you want to move insulation, move stuff around. The easiest way, if you have a crawl space that has a framed foundation wall that is not insulated, that's the easiest place to, if you have that kind of type of configuration, it should be very easy to verify if your anchor bolts or your anchor straps are in the proper locations. So 6 inches on center. Bolts must be extended into the concrete or grouted cells of masonry concrete units at least 7 inches. The bolts must be located in the middle third of the plate width. It is common to see an anchor bolt placed near the edge of the wood or the sole plate. The requirement for placement of the bolt within the middle third of the wood plate width allows some flexibility while providing for minimum edge distance. So a lot of that comes down to prep and planning on the contractor side. So if they weren't paying attention or they had a new, a lot of times it comes down to somebody that's new to the industry that incorrectly puts the bolts in places. If a bolt is on the outside third of the foundation wall, then it's highly recommended that a new anchor location be installed, and with a wedge anchor or well, generally you're going to have a wedge anchor, or I can't think of, or an epoxy anchor. Um, that will then be in the middle third to maintain that connection. So what you don't want is all of the bolts installed on, say they put the bolts all in line, everything's even, but they had to move the sill plate, and now all your bolts are on the edge. Well, if you get a tornado or a hurricane or some type of a wind event or seismic event, you have a earthquake or something. If the anchor bolts are installed on the outside edge, the movement, the shaking, the uplift can all cause that board to split, and then for you to lose the positive connection to the foundation. So you want to make sure that your anchor bolts are in the middle third of the board, and you're spaced no more, what is it, than 6 bolt lengths from the edge. What is it? Bolt must be located at least 12 inches from the end of the plate section. Again, that's to make sure that the board doesn't split and you lose that positive connection. And again, nuts and washers on all of these. All right. A nut and washer must be tightened on each anchor bolt. No loose nuts, no missing washer. There must be at least 2 bolts per plate section. I have seen many new construction sill plates that only have 1 bolt right in the middle instead of 2 bolts on the outside. 1 bolt is not adequate. That bolt under those extreme events, wind, seismic, water, whatever, that can twist under load or under stress, and then you can cause that wall to become skewed, which can put more stress on the rest of the structure. And you want to make sure you have positive connections with no potential for movement or issues. The bolts must be located at least 12 inches from the end of the plate section. The bolt must be located at least 7 bolt diameters from the end of the plate section. There we go. It is common defect to see a bolt placed on the very end of a plate section. There are exceptions, including walls that are 24 inches total in length or shorter connecting offsets. Or shorter connecting offset braced wall panels, and walls 12 inches total length or shorter connecting offset braced wall panels. When braced wall panels are supported directly on a continuous foundation, the wall wood sill plate or cold formed steel bottom track should be anchored to the foundation appropriately. In some areas, large square plate washers are required to compensate for oversized bolt holes that are often overbored. All right. Notches and holes. Notches in a joist. So notches can potentially reduce the structural integrity of solid lumber joists. Therefore, there are limits on the size and location of notches to solid sawn lumber members. Notches in solid lumber joists, rafters, and beams should not be longer than 1/3 of the depth of the member, depth divided by 3, and should not be located in the middle third of the span. Notches at the ends of members should not be more than 1/4 the depth of the member, depth divided by 4. Notches located in the outer third of the member should not be more than 1/6 the depth of the member, depth divided by 6. If engineered wood members such as trusses and I-joists are notched, the effects of the notches must be planned and approved by a structural engineer who designed the member. And many times, if it has been modified, if a if a manufactured structural support has been modified and been modified by an engineer, there should be some type of a letter or document in very close to the modified location. If there is not some type of a stamp, structural engineer's paperwork or whatever, then many times it's been modified without engineer's approval and needs to be recommended for evaluation and upgrade. Bored holes in solid lumber members can have the same effect as notches. The bored hole can reduce the structural integrity of the member. The diameter of bored holes in solid lumber members should not exceed 1/3 the depth of the member. Holes should be at least 2 inches from the top or bottom edge of the member and should be at least 2 inches from any other hole or notch in the member. If you've been an inspector for any amount of time, you will know that you were going to see these damages, these modifications a lot, especially older homes. And newer homes too. I mean, I've seen the bottom and top, well, mainly the top chord of a manufactured I-joist is cut through all the time by plumbers for the most part. I would say most of the modifications done to structural members are done by plumbers. And it's from a plumber's perspective, they have requirements too. They have to have the toilet so far from the wall, so far from the back wall, so far from the side wall. And many times it is very difficult for them to move their components to a proper or outside of the structural member. And so what often happens is, say you have to put a toilet here, there's no way that you can move it. The cabinet, the cabinet's already there, the wall's already there, or what? Well, I would say that is not how it happens. So in a new construction home, many times the plumbing is roughed in before the cabinets are installed. But what comes down to is a plumber is not a structural contractor. And so many times they will make that modification. Maybe they do tell the GC, maybe they do tell the framer, and then it gets lost. The modification, they went and told them, they said, hey, I had to modify this. You need to come back and add strapping or add supports or change it or move it around. And then it doesn't get done. It gets lost. They're doing something else. They forget about it. A lot of contractors are like me. We have ADHD. We're contractors for a reason because we don't do well in school. And so we became contractors, which obviously there's nothing wrong with that. We love what we do. But when you have a lot of people that have ADHD, if we don't write things down, we don't set reminders, then it gets lost to the void. And so then things are modified, and now the structural integrity is lost of that modified member, and it's not caught during whatever inspections, modifications, or whatever. So it might not be the plumber's fault, but the plumber is the one who made the modification. And then, because we see the plumbing coming through the modification, we assume that the plumber is the one that didn't make the change, but a plumber, again, is not a framer, or is not a structural contractor. So they're not going to be the ones to fix it. But they need to be the ones to tell somebody, and then that contractor has to be the one to go fix it. Um, let's see, where was I? The diameter of bored holes in the solid lumber member should not exceed 1/3 the depth of the member. Holes should be at least 2 inches from the top or the bottom edge of the member, and should be at least 2 inches from any other hole or notch in the member. This diagram is fantastic. A little side note, I use diagrams all the time. I recommend you guys use diagrams all the time. It does a couple of things. One, I am a very visual learner, and so if I see a diagram, a lot of times I can picture that diagram. I can picture depth divided by three, the depth, depth or length divided by three to determine, these locations. If I see writing on a paper, I'm never going to remember writing, but I can remember a diagram. So I use diagrams in my reports. I use diagrams in my reference material when I'm doing investigations, when I'm doing my inspections. Um, and InterNACHI has a fantastic diagram library, and they're constantly improving it. So I would recommend checking back on the InterNACHI diagram library and seeing all the changes that they have. Um, and they, they're always staying on the up and up with code changes. So if a code changes, they'll make a new diagram, or eventually they'll make a new diagram. Depends on, what's going on with the designer or whatever. But um, and then the other thing that helps with diagrams is that if you take a picture of a maybe a notch or a bored hole and it that it clearly doesn't meet standard, but then you can have a diagram included in your report or to reference back to, then that takes um the opinion of the defect out of the observation. So what I mean by that is I got really frustrated early on in my career when I would call out maybe notching in a joist that was outside of standard, and I would put it in the report. They would send my report to the builder or to a contractor, and they would be like, "Oh no, that's the code." And then the client comes back to me or the realtor comes back to me and they're like, the builder's saying that this is the code. Can you explain this? And the burden of the burden to prove that I was correct is on me then, right? So instead of putting that burden on me, I put the diagram in the report with my observation, and now we have a third party verified diagram that goes along, and it's incredibly difficult for a builder or a contractor to argue with a third party diagram. I obviously did not create the diagram. Somebody had to create it. Now, it's getting easier with AI, but by putting that in there, you take off the burden of proving that it wasn't a code. You take that and you put it on the contractor to prove that it is the code. And so you'll get less phone calls when you include diagrams on asking questions or having to prove your observation. Um, Now, be very careful when using diagrams. I got caught in this in that the software that I used, it allowed me to add diagrams to my pre-written comments, but codes change. Codes change every year, or they can change every year. And if you're not careful, you will put a diagram into your report that is now outside of the code requirement or outside of the standard. So if you are going to put diagrams in your report, make sure that when you're writing your report, you're verifying that the diagram that you're using is still applicable to the situation. All right. Standard 11, masonry chimney. A masonry chimney should terminate some distance above a roof in order to provide adequate upward draft in the chimney. Masonry chimneys should extend at least 2 feet higher than any portion of the building within 10 horizontal feet. The minimum height of a chimney should be 3 feet. We're going to go over this stuff here in a minute. I'm going to read this whole section though. So, clean out openings should be provided within 6 inches of the bottom of the flue within the masonry chimney. There is an exception for cleaning a fireplace at the fireplace opening. The upper edge of the cleanout should be located at least 6 inches below the lowest chimney inlet opening. The height of the chimney's cleanout opening should be at least 6 inches and should not be made of combustible material. Any portion of a masonry chimney located in the interior of the building, such as an attic space, should have at least 2 inches of airspace clearance from combustibles. As heat is transferred through the masonry material, any combustible material in close proximity to the heated walls may reach the point of ignition. The airspace helps the dissipation of heat. Chimneys with a dimension parallel to the ridgeline greater than 30 inches that does not intersect the ridgeline should have a chimney cricket. The cricket should be flashed and counterflashed in the same manner as a normal roof chimney intersection. All right, where are we at? Oh, I tell you what, we're going to take a 10-minute break. I'm going to answer some questions and then we'll dive back into masonry chimney. All right, let's see what we got here. Michael Stewart, in a basement, if a sliding glass door in the next room over from a bedroom, is the next room over from, does the bedroom still require an egress window? Yes, it does. Um, yeah, Gary Stevens, thank you. But yes, Michael, it does require an egress window. Otherwise, it's, again, you probably have to talk to a realtor, but I don't believe it would be considered a bedroom if there is not a if there is not an egress window in that bedroom. Daryl, in older home construction in the Midwest, do not have true bolts or were just observable with a ram gun bolt at the sill plate. Is it a defect or a local AHJ? So, from my experience, ram bolts are allowed for the internal walls. Um, and because if you don't have if you don't have a bolt with a washer, then you get, being in the Midwest, if you get a tornado, if you don't have a washer that can hold the sill plate to the foundation, that wall can easily pull through the ram bolts or the true bolts. If you got to have an inch and a half washer in order to ensure that the foundation plate does not pull through the bolt head. That's the whole point of having a washer on there. So I would highly recommend that that these that there be washers and bolts attached. Instead of just the ram gun. Again, you can have it on the interior walls, but on the outside foundation wall, this sill plate needs to have a bolt with a washer. Stephen, does the end notch apply only to the top of the beam, or can it be on the bottom of the beam also? You can have a notch in the bottom of the beam at the end of the beam, but that is the only location. Inspectors, should they invest in AI? To each their own. I I like AI. AI has helped me a lot. Now, I will give you a couple instances. I have inspectors. I'm a manager of a multi-inspection firm, and I have inspectors in multiple states. And so I asked one of my inspectors to go through the different SOPs in the different states and to provide a list of differences. And so we tried multiple times to just use AI to provide those differences, and every time AI got it wrong. So I would say yes, use AI, but verify AI. It can cut out a lot of the initial work, but it doesn't keep you from having to do your due diligence and verify the information that AI is putting out. Like a little disclaimer here. Again, remember, we are not code inspectors, right? We're not code inspectors. We use code to reference. We use code to identify potential defects. Our standards come from code, but there's a lot of times that we want to go above and beyond code because code is actually the bare minimum for construction. If you were to reference the National Roofing Contractors Association or the National Concrete Association or any of the other associations out there, just like InterNACHI, where we set standards, a lot of times the industry standards or the specific trade standards go well above and beyond code requirements. So keep that in mind. Code is the bare minimum for construction. I mean, if a house is not built to code, generally it's not safe. And knowing how the code is created is super important. And this is where I've gotten a little pushback from builders in that, they'll say, well, the code is made by a bunch of engineers who are sitting in an office and they don't have any practical experience and so on and so forth. So if you actually look at your code book, which I don't have my Arkansas code books anymore, but if you actually look at a code book, um, for Arkansas specifically, they take the national code, and no matter if you're taking the national code or your local state code or local AHJ, like when it comes to Arkansas, we have a group of code advisors, which are normal everyday HVAC contractors, plumbing contractors, electrical contractors, they're the peers of the tradespeople in the industry, and they're the ones that evaluate the code. They're the manufacturers of industry materials. They're every facet of code is created by our peers in the construction industry. It's not just engineers who don't have practical experience that are creating these things at the national level and at the state level and at the local level. When your local ordinances are being put into place, they are being evaluated by your local peers, your local electricians, not just your state electricians, but your local electricians or your local plumbers or whatever. So, so there's a perception out there to some builders and some contractors that the code is made by people who don't know what they're talking about, when in fact it's the exact opposite. It's the people that work with it every day that determine what is viable, what is not viable. So again, we are not code inspectors, but we need to use code to our advantage to determine what is best for our clients. Again, code is bare minimum. Um, the but when you're writing your reports, because we are not code inspectors, do not put code references in your report. Um, Once you start putting code references in your report, a anybody can then take your report. Okay, so say, our industry, home inspection industry, is one of the most litigated industries out of all construction industries. So with that in mind, when you write your report, you need to make sure that you are not setting a precedence. So there's a thing in litigation, in lawyer speak, and I'm not giving recommendations for law. Telling you what I've known, what I've seen in my experience. You are putting if you are putting code in your report, then you are setting a precedence that you are a code inspector. And you do not want to set that precedence because a lawyer can take you, if you, for whatever reason, your report is used in litigation, is used somehow in a lawsuit between the builder and the client, or the client and a contractor, or whatever, then if you are not prepared to be able to quote code, to go into in front of a lawyer and back up your recommendations and stuff, then don't be putting code in your reports because we are not code inspectors. So just keep that in mind. Definitely use code, use diagrams, use those things, but don't be quoting code references or saying this is the code, this is not the code, those types of things. So just protect yourself from liability. Okay, so back to the chimney stuff. All right. So the 3-2-10 rule, the 3 feet high, or the uh, 3-2-10. Yeah, I think that's anyway. The chimney must be 3 feet high, 2 feet higher within any portion of the building within 10 feet horizontally. 3-2-10. So most times a chimney, when it's originally installed, if you have a chimney that was originally installed, a lot of times that home is going to be much older. It's very hard to find new chimneys, new true chimneys being installed today. That said, when a chimney is installed, most chimneys meet that rule. They are installed correctly. The chimney contractor wants to make sure that his chimney is going to operate, it's going to work as intended. The problem comes when you modify the home, and then the modification gets that chimney outside of that 3-2-10 rule. A lot of times, unless the chimney is obviously out, if on an existing home, no modifications have been done, most of the time you're not going to find an issue with the 3-2-10 rule. But if you have a two-story addition added to the home, that could modify the 3-2-10 rule. You add an architectural element where you add a dormer to the house, that can change the 3-2-10 rule. So look for those kind of modifications or things that look out of place that maybe were not originally installed like that when the chimney was originally installed, and then you can evaluate the chimney that way. All right, chimney cleanouts, that's pretty straightforward. If you have a chimney cleanout, the reason why you want it located Let's see, the upper edge of the cleanout should be located at least 6 inches below the lowest chimney inlet opening. The chimney cleanout should be provided within 6 inches of the bottom of the flue within a masonry chimney. You want to make sure that you have room for access for the cleanout. You want to make sure that the ash and everything is not going to spill out of the door, those types of things. Chimney doors are, or chimney cleanout doors are most often the thing that I call out as a defect when the chimney door is on the exterior, especially, and it's rusted shut, it's degraded over time. And or you have a chimney that maybe the flue liner had gone bad. Maybe you had a clay flue liner. The flue liner has gone bad, and so they wanted to keep the fireplace aspect of it. So they put a new liner in, which is generally made of metal. And then because they didn't want to replace the liner, and they had to put a new liner in with the metal flue liner, then they had to do a fireplace insert. Well, that insert then a lot of times that blocks the ash cleanout from being used, and sometimes that ash cleanout is forgotten about after the fireplace insert has been installed. Well, you go and you're inspecting the home, and you're doing your initial walkthrough on the inside. You notice that they have a fireplace insert now. Well, then you should be looking for an ash cleanout. Open the ash cleanout, and a lot of times there's still tons of ash in that thing. Or it might be growing plants because water is getting in there somehow, or there's dead birds or dead animals in there. So just definitely keep an eye on the door, on the ash cleanout, and make sure it's cleaned out and everything is properly maintained from the chimney itself. All right. Um, and then crickets and or chimney crickets or chimney saddles. You just keep in mind we find a lot of chimneys because that is I don't know if it's fairly new. I don't know when that rule was put into place, but we have a lot of chimneys here that are wider than 30 inches that don't have a cricket or a saddle installed on the backside. And in those instances, many times, almost I'd say probably 90% of the time, you go up into the attic and you look at the uphill side of the roof decking, and you'll find water damage on the roof decking there. And so again, the amount of water that is flowing down the roof that is hammering the backside of that chimney, it can have a lot of pressure and it can flow up and underneath the flashings and the counter flashings and then get into the roof structure, or the water is hitting it, and or the back is as you're having accumulation of tree leaves or debris, and then that can hold water and push water up, underneath the flashings and get into the roof decking. So be especially careful when walking around chimneys, especially on older houses, because a lot of times that roof decking might be rotted out, 3, 6 inches away from that chimney. So don't be standing right next to that chimney because you don't know. A lot of times I inspect my roof before I inspect the attic, and I don't know what kind of rot has happened around that chimney over the time. Maybe it's been repaired, maybe it's been replaced, but especially if it doesn't have a cricket or a saddle, be very careful around penetrations that large in those areas. All right. Attic access. Mechanical equipment in attic space. Let's see, where are we at? Oh, I need to get going. Okay, mechanical equipment in attic space or in underfloor crawl space should be accessible for service and removal. In addition to an adequately sized access opening, a passageway should be provided. In an attic, the passageway should be made of solid flooring. There should be an opening to the space and clear, unobstructed passageway large enough to allow removal of mechanical appliance. The passageway should be at least 30 inches high, at least 20 inch, excuse me, at least 22 inches wide, and not more than 20 feet in length when measured along the center line of the passageway from the opening to the appliance. There are some exceptions. The passageway flooring should be at least 24 inches wide. A service area is required in front of the mechanical equipment with a minimum dimension of 30 by 30 inches. Light fixtures should be installed to illuminate the passageway and the mechanical appliance. A switch should be installed near the entry to the passageway, and electrical receptacles should be installed at or near the mechanical appliance to allow for safe and convenient maintenance and service of the appliance. The rough framed opening in the attic area should be at least 30 inches by 22 inches. If the opening to the attic area is installed in a ceiling, there should be at least 30 inches of vertical headroom in the attic space measured above the access. Uh, in older homes, you're going to find all kinds of issues with those measurements, those requirements. Um, just it's up to you. I know that every contractor that goes into the attic after you would appreciate you making it known that those requirements are not met, and to have that upgraded to the as desired by the seller or by the buyer or whatever. But keep those in mind. But again, many houses in my area up until like what 20, 30 years ago do not meet these requirements. So we find it a lot in older homes. Clothes dryer. Uh, Clothes dryer exhausts pose a different problem compared to other exhaust systems because the air they carry is damp and infused with lint. The exhaust of a dryer vent must or the exhaust of a dryer must vent outside and not discharge into an attic or a crawl space because the wooden structural members could be affected. Exhaust vents should have a backdraft damper installed to prevent cold air, rain, snow, rodents, and pests from entering the vent. The length of a clothes dryer exhaust ensures that the dryer exhaust blower will be able to push sufficient air volume to take away the damp air and lint. The length can be increased only when the make and model of the dryer is known or when an approved blower fan calculation is provided. The maximum length of the exhaust duct does not include the transition duct, which means the flexible vent that goes from the back of the dryer to the wall or the floor outlet. And screens are not permitted on clothes dryer exhaust vents because they can trap lint and other debris, which poses a fire hazard. I will tell you, I see new construction homes all the time where they are installing, most of our dryers now in new construction are going through the roof and terminate on the roof. And a lot of times these contractors, whether I don't know if it's the roofer that's installing the roof mounted dryer exhaust or if it's the HVAC contractor, I believe, is who is responsible for installing the dryer vent extension. But either way, a lot of them are using bathroom vents to install as a dryer vent, and those bathroom vents have a screen on the end of them. You cannot have a screen on the end of your dryer vent or on the end of your dryer vent termination. I just called one out last week. It was a new construction home, like $600,000 home, and it had a screen on the dryer vent. And I looked at all the houses around me, and all of them had screens on their dryer vents. The maximum length of a clothes dryer exhaust duct should not be greater than 35 feet from the dryer's location to the wall or the roof termination. For each 45-degree bend, the maximum length of the duct is reduced by 2.5 feet. For each 90-degree bend, the maximum is reduced by 5 feet. One thing I will say as far as dryer vents are concerned, it's a fairly new requirement that dryer vents not only be made out of metal. We have tons of homes in my area that are using um, the green pipe, which I think is what Schedule 40, and then and or PVC as dryer vent extensions. Those are no longer recommended because you have the hot dryer lint that is passing through the plastic ductwork, and it can build up. Static electricity, and then as air keeps passing through, it dries out that lint, and you can get electrical charges that can create a spark and create a dryer fire. So you definitely don't want that. Now, I will say there are a lot of slab homes where they had the dryer vent going sub slab and coming out of the side subgrade and then coming out. So those, obviously, if you see those, just know that if the dryer extension is going sub slab, most of the time it's PVC, and many times they are going to be filled with water or have some type of water, so that when the dryer lint passes over it, it comes into contact with the water and then it cakes into the bottom of the dryer vent, which is why they're no longer recommended to go sub slab. Which is why most dryer vents are now going up through the roof or coming out of the side of the home. But anymore, they're putting dryer or laundry rooms in the middle of the home instead of on the edge of the home. Obviously, if it's on the edge of the home, it's really easy to terminate out of the side of the wall. But if you're putting laundry rooms in the middle of the home, then the only option is to go through the roof, and then you're working against gravity, so you're more likely to have dryer lint buildup. So it's more important than ever to ensure that your dryer lint is being cleaned out yearly, and making sure that there's no screen on the dryer vent termination on the roof. Standpipes. Standpipes must be trapped. The standpipe height should be at least 18 inches and no more than 42 inches above the trap weir. The illustration shows the trap weir. Access to all standpipes, traps, and drains should be provided for cleaning and rotting. The standpipe itself is often concealed, but there must be open access at the point of indirect connection. A standpipe can serve as an indirect waste receptor. To prevent overflow, the height limitation is necessary to provide some retention capacity and head pressure. The height limitation controls the velocity of the waste flow at the trap inlet. The limitation is necessary when a high rate of discharge enters the indirect waste pipe, such as that from a closed washer. Excessive velocity will siphon the trap. A laundry tray tub waistline is permitted to connect into a standpipe for the automatic closed washer drain. This standpipe should not be less than 30 inches as measured from the crown weir. The outlet of the laundry tray should not be greater than 30 inches horizontally from the standpipe trap. All right, pretty standard. I don't think I've ever really come into contact with any defect when it comes to this installate with these requirements. So you might in yours, I would imagine it's more common in older cities where you put a lot of your clothes washers and dryers in your garages, or they were originally installed in garages, or maybe they were added after the fact where they were installed in a garage, and a lot of times, or a basement, and a lot of times because all of the plumbing is visible, or maybe it was, in addition after the fact. This is where you might come into issue with these. I will say the only issue I've ever really had with a clothes washing machine drain line is where a client, I inspected a home for a buyer. They moved into the home, and within like 2 months, I got a phone call, and they said, "Hey, I'm getting this terrible sewer smell in my laundry room. Did you miss something? Did you forget to do something or whatever?" And so I went out and I looked at it, and turns out they got a little over ambitious and ran the drain hose from the washing machine too far down the drain line. And every time the force of the pumped water coming out of the washing machine siphoned out the P-trap, and that was allowing sewer gases to come up into their laundry room. So that was an easy fix, but that's the only time I've ever had an issue with standpipe. TPR valve discharge. There are 13 requirements for a discharge pipe serving a TPR valve. 1, the pipe should not be directly connected to the drainage system. The pipe should discharge through an air gap located in the same room as the water heater. The pipe should be constructed of materials tested, rated, and approved for such use, typically as a hot water line. Anything that's rated to run hot water is generally used or can be used as an extension. The pipe should not be smaller than the diameter of the outlet of the valve served and should discharge full size to the air gap. The pipe should not have valves or T-fittings installed. The pipe should not have a threaded end. The pipe should serve a single relief device and should not connect to piping serving any other relief device or equipment. The pipe should discharge to the floor, to an indirect waste receptor, or to the outdoors. Where discharging to the outdoors in areas subject to freezing, discharging pipes should first be piped to an indirect waste receptor and then through an air gap located in a conditioned space. The pipe should not terminate more than 6 inches above the floor or waste receptor. The pipe should discharge in a manner that does not cause personal injury or structural damage, generally meaning it needs to be discharged no more than 6 inches above grade if to the exterior. The pipe The pipe should be installed so as to flow by gravity. The pipe should discharge to a termination point that is readily observable by the building's occupants. The pipe should not be trapped. An appliance used for heating water or storing hot water must be protected by a relief valve. A combination temperature and pressure relief valve or separate temperature relief and pressure relief valves prevent a water heater from exploding. They are emergency devices. They are not intended to function continuously. The pressure relief valve should be set to open at 25 psi above the system pressure, but not over 150 psi. The relief valve setting should not exceed the tank's rated working pressure. Temperature relief valves should be installed within the top 6 inches of the tank. The valve should be set to open at a maximum temperature of 210 degrees Fahrenheit. Discharge from a relief valve should be immediately investigated. A discharge indicates that something is wrong with the system. The discharge point should be conspicuous. The termination of a relief valve discharge pipe should always be visible and conspicuous. An air gap is necessary to prevent backflow and contamination of the potable water system. The discharge pipe must not be reduced in size and must not be less than the size of the relief outlet. A reduction in size will act as a restriction and will impede the flow of the discharge. Relief valves must not be exposed to freezing temperatures. The slow drip of a leaking valve in freezing temperatures would cause ice to form and would restrict the discharge and disable the valve. I have seen every one of these observations in the field that are incorrect. So every single thing on this list and everything that I read out, I have seen in the field as being incorrect. So I would pay special attention to each one of these items and the installation and how it's installed in a water heater, because you will find these defects all the time, especially on older units. Standard 16 expansion tanks. So when a water heating appliance is connected to a water distribution system, migration of the heated water into the water distribution piping is possible. In typical water distribution systems without some type of pressure relief, heated water will expand into the water service line and into the public main. If the expansion is not relieved or accommodated in the system, high pressure can develop and that can damage pipe components and the water heater source. For water service pipe sizes up to and including 2 inches, a device for controlling pressure shall be installed where, because of thermal expansion, the pressure on the downstream side of the pressure reducing valve exceeds the pressure reducing valve setting. A device for controlling pressure should be installed in a system that has a water heating appliance and a backflow prevention device, check valve, or other device because thermal expansion will cause an increase in pressure. Okay, so while the tanked thermal expansion tank is very common, newer expansion valves are now becoming more prevalent. So instead of the water expanding into the tank, um, because tanks generally have been having an issue of rusting through because you get the variation of water levels inside of the tank. When you do that in proximity to water, now I know a lot of them have baffles and there should be a separation between air and water, and the baffle should do that. But that even that minute fluctuation of water can cause that tank to rust out around the edge of where the water line is. But I would say most rusting through locations is either going to be on the bottom of the tank, whichever, if no matter if that's hanging downward or if it's oriented upward, whatever the bottom of that tank is, a lot of times you're going to find rusting come through there. So plus the weight of those things is extremely heavy, and with the introduction of PEX piping, now you're having to strap the tank and make sure it's adequately supported. And so to get around that, a lot of contractors, a lot of builders are now starting to use an expansion valve. So it's a very simple looking valve. It's on the incoming water line, just like the thermal expansion tank is. And that valve will then have an output drain line that will go into the DWV system, or it'll go into the um, uh, the drip pan, which then goes, to the DWV system or goes to the floor of the garage or wherever the drain pan is dripping to. Um, so you'll see those things. Now, I will say, so when I first started identifying the lack of thermal expansion tanks, and then the advent of tankless water heaters, I incorrectly called out the need for a thermal expansion tank when a tankless water heater was installed. Um, I didn't read the code or fully understand what was going on, so I called it out a few times, and then I was corrected by the builder. Now, when I was corrected, I then did a deep dive into the code and the installation requirements. I read the installation requirements of a thermal, or I'm sorry, of a tankless water heater, of the thermal expansion devices, all those things. And what I come to found out is, and I've kind of already mentioned it here, but if you put um, a hot water circulation pump on a tankless on the outlet side of a tankless water heater, you have now created a closed system, which then does require a thermal expansion valve or a thermal expansion tank. So if by installing a device on the water system that then uh, was originally an open system, when you like a water heater, where you don't have a tank that will increase pressure and decrease pressure as it heats. But then you put a device on it that creates a closed system. Then you do have the opportunity to have pressure buildup on the lines, which would require a thermal expansion valve or a thermal expansion tank. Roof vents. An open vent pipe that passes through a roof should extend at least 6 inches above the roof. If snow accumulation is expected at various times, the vent height should be increased so that the vent pipe will be at least 6 inches above the anticipated snow accumulation. The height in snowy areas is often determined by the local building official based on local information. Most roofs are not designed for occupation, so the main concern is to simply vent the gases and odors above the roof. If the roof is used for a purpose other than weather protection, such as a deck that can be occupied or an observation platform, the vent extension should extend above the individuals occupying the roof, at least approximately 7 feet above the roof. Pretty straightforward. Uh, Traps. In general, each plumbing fixture should be separately trapped by a water seal trap. A trap or water seal keeps sewer gases from emanating out of the drainage system. A trap is a simple U-shaped pipe arrangement. The shape offers minimal resistance to flow. The water seal prevents sewer gases and airborne bacteria from entering the interior air of the building. Traps shall have a water seal of at least 2 inches and at most 4 inches in depth. Traps for floor drains should be fitted with a trap primer or should be of the deep seal design. Traps should be level with respect to the water seal. Traps should be protected from freezing. Traps should be protected from siphonage, aspiration, and back pressure by an approved venting system. The only type of fixture trap permitted is the P trap. All other traps, including bell traps, drum traps, S traps, and traps with moving parts, are prohibited. The vertical distance from the fixture outlet to the trap weir should not be greater than 24 inches. The limitation of the vertical distance is designed to control the velocity of the drainage flow. If the trap is located too far from the fixture, the trap may self-siphon the water out of the trap. The horizontal distance from the fixture outlet to the trap weir should not be greater than 30 inches measured from the center line of the fixture outlet to the center line of the inlet of the trap. It is desirable to locate the trap as close as possible to the fixture to avoid the need for a long drain pipe on the inlet side of the trap to be installed. There will not be enough flow energy to move waste in the horizontal distance if the horizontal distance exceeds this limit. Fixtures must not be double trapped because the unnecessary additional restriction of flow and the increased potential for stoppages. Double trapping can cause air to be trapped between two seals, and the air-bound drain will block airflow. Um, I think pretty standard understanding. I will tell you, Lowe's and Home Depot still sell S-trap kits. So you'll still see, I don't know if you can read that, but they still sell S-trap kits, even though this has been um, out of code for a long time now. I don't know, probably what, 20 years probably. But Lowe's and Home Depot still sell S-traps. So you can still see new S-traps being installed. Oop, oh well. Oop. Panel workspace. Um, Panel workspace is needed to allow for safe clearance from any live components. It also provides enough room for the free movement of a person who needs to examine, adjust, service, or maintain the electrical equipment. The space shall be at least 36 inches deep. Workspace should be at least 30 inches in width in front of the electrical equipment and not less than the width of the electrical equipment. Oh, excuse me. If the panel board is wider than 30 inches, the workspace must extend its full width. The workspace should be clear of obstructions. The workspace's height from the floor or platform should be at least 6.5 feet. There must be access provided to the workspace at the panel. The workspace must not be designated for storage. Panel boards and overcurrent protection devices must not be located in enclosed closets, bathrooms, or over stairway steps. The workspace must have a manually controlled artificial illumination installed. A space directly over the panel board that extends from the top of the panel board to the structure of the ceiling or to a height 6 feet above the panel board, whichever is lower, should be provided. The space should be equivalent width and depth of the electrical equipment. This dedicated space above the electrical equipment should be kept clear of components not related to electrical equipment, such as plumbing pipe, HVAC ducts, etc. There should not be any interference with the direct run of cables or conduits to the electrical equipment. A suspended ceiling with removable panels may encroach into the dedicated space above the panel. According to the 2018 IRC, a dedicated space above and below the panel board equal to the depth and the width of the panel board must be maintained clear of all ducts, piping, and other foreign items to allow for maintenance, inspection, future work, and future installations. Again, just like with a temperature pressure relief valve, you're going to find encroachments into this space all the time. Just do your due diligence and document and put it in your report. Electrical service conductors. No clearance. Let's see. 3-foot clearance is based on close proximity of people to the service conductors. The clearance reduces the potential for damage to the service conductors and reduces the risk of accidental contact with electrical conductors. Open electrical service conductors and multi-conductor cables that are not installed in a raceway or provided with an approved overall outer jacket should have a clearance of at least 3 feet from the sides of doors, porches, decks, stairs, ladders, fire escapes, and balconies, and from the sides and bottoms of operable windows. The clearance from windows that can open applies only to the sides of the window and below the window opening. Service conductors and drip loops located above a window opening are considered to be out of reach. No clearance is required from windows that do not open. Electrical service conductors should have a vertical clearance of at least 8 feet above the roof surface. There are exceptions. The 8-foot vertical clearance above the roof surface should also be maintained for at least 3 feet horizontally from the edge of the roof, except when the service drop is attached to the side of the building. The 8-foot clearance may be reduced to 3 feet where the slope of the roof is 412 or greater, because there will likely be minimal travel across the roof with such a steep slope. The clearance may need to be increased at more than 8 feet in height if the roof deck is expected to accommodate occupants, such as in the case of a rooftop court or sun deck, or where the roof is also the upper deck of a parking garage. The service drop cable supported on and cabled together with a grounded bare messenger wire, the vertical clearance should be at least 10 feet at the electrical service entrance to buildings and at the lowest point of the drip loop of the building's electrical entrance, and above areas and sidewalks accessed only by pedestrians. Where there is no anticipated vehicle traffic, a 10-foot minimum vertical clearance is needed. Where vehicles are present, higher clearances are needed. The vertical clearance should be at least 12 feet above residential property, yards, and grounds and driveways. The vertical clearance should be at least 18 feet above public streets, alleys, roads, parking areas that are all subject to truck traffic. I would say most of the time, clearances will all be met unless modifications to the home have been added, like house additions or decks, those types of things. Particle board sheathing. So I'm going to kind of quickly go over this one because particle board sheathing is rarely going to be viewed by an inspector, but it is important to know some aspects to particle board sheathing. So particle board is a generic term used to describe panels made of pieces of wood and particles combined with synthetic resin and other binders bonded together under heat and pressure. The particle board panel should not be exposed to the weather. Particle board tends to absorb moisture and swelling can occur and delamination. It requires protection and inspectors should check for weather protection. So oftentimes where I see exposed particle board is on the underside of a deck where the siding structure has not been continued underneath the deck. So maybe the deck ledger board has been attached to the band joist of the house, but you still have, 2 or 3 inches of particle board that extends below the deck ledger board, and that's most often where I see exposed sheathing is underneath decks. So if you see exposed sheathing underneath decks, that needs to be called out and needs to be identified for repair and replacement. And then just so you know, when they do install particle board, none of the corners should line up. Everything should be offset. I think that same with roof decking. Temperature, pressure relief, and explosive power. So, quick math lesson here since we've already talked a lot about the temperature, pressure relief valve. So, let's assume a water heater tank has 30 gallons of superheated water inside it. Assume the capacity is 50 psi and the water pressure is superheated at 300 degrees Fahrenheit. Remember that superheated water wants to change into steam. If the tank ruptures, then 30 gallons of superheated water will instantaneously turn into steam in the outward direction through the rupture. So that at Note that at 50 psi, water flashes into steam at the 297.7 degrees Fahrenheit. The energy released equals more than 2 million foot-pounds of energy, similar to the explosive energy released by 1 pound of nitroglycerin. To further understand this power, a 16-inch gun on the battleship USS Iowa produced 7.5 million foot-pounds of energy. If you've never looked at, oh gosh, I can't think of the show. I'm sure you guys know what I'm talking about. Anyway, there's a show where they dispel something Mythbusters. Mythbusters did a really good episode on exploding water heaters, and it proved why the functionality of temperature pressure relief valves are so important. So if you've never had an opportunity to go look at one of those videos, search them up on YouTube and go look up that episode. Or there's plenty of other videos out there by different plumbing contractors and water heater manufacturers that show what happens when a temperature pressure relief valve is not installed correctly, not working correctly, and what can happen to a home. Many times it shoots upward through a home and like a rocket. So anyway, very interesting videos to watch. So FVIR. FVIR stands for Flammable Vapor Ignition Resistance. In 2003, a new standard for water heaters was developed and phased in. It states, the water heater should not ignite flammable vapors outside the water heater created by spilling of gasoline onto the floor. The Consumer Product Safety Commission found that thousands of fires, injuries, and deaths are related to water heaters. Most of these incidents were caused by improper storage, or handling spillage of gasoline. If the tank is in compliance with the FVIR standard, it does not have to be raised 18 inches in the garages or similar locations unless required by the manufacturer or local code authorities. Pretty straightforward. Gonna kind of move on. So look for the FVIR, and if a water heater doesn't have an FVIR, the flammable vapor ignition resistance, meaning that the ignition chamber is completely sealed, then it does need to meet the standard recommendations for 18 inches up off the floor of the garage. Island fixture venting. The air admittance valve should be installed. Let's see. Okay, let me back up. So a clean out should be installed for the island fixture vent pipes to provide access for rotting, cleaning, and maintenance of all vent pipes below the flood level rim of the fixtures. Air admittance valves are permitted on vent fixtures at island structures and kitchens. Island vents should extend vertically above the drainage outlet of the fixture that is being vented before venting downward, vertical or horizontal. Island fixture venting should not be installed for a fixture other than a sink or a lavatory. Such a fixture is permitted with a dishwasher waste connection, a food waste grinder, or both. Air admittance valves are pressure-activated one-way mechanical vents. They are used when venting through the building's roof structure when venting through the building's roof structure is not available. This type of vent is common for kitchen sinks, especially when the fixture is installed in an island structure. When wastewater is discharged, the valve opens, releasing a vacuum, and air is allowed to enter the vent for proper drainage. Waste outlets for sinks should be 1.5 inches minimum. The sink should have a strainer or crossbar to restrict the clear opening of the outlet. The drainage pipe for food waste grinder should be at least 1.5 inches. A dishwasher, food grinder, and kitchen sink can all discharge into the same 1.5 inch waste drain pipe. The branch water supply line for the dishwasher and kitchen sink should be at least a 1/2 inch pipe. The hot should be installed on the left and the cold on the right. The size of the P-trap drain should be at least 1.5 inches. So here's just a quick, there's a lot of different air admittance valves out there. Very basic devices, but you're only required to have one vent going out your roof, one DWV vent going out of the roof. All your other plumbing vents can be AAV vents. Now, if you do find that in a house, you need to make sure that if they're terminated in an attic, that they're terminated above the insulation levels, or if they're underneath sinks, they need to be above the trap. Shingle roofs and high winds. When composite shingles are not securely attached, they can be damaged or torn by high winds. When this happens, the interior of the structure becomes vulnerable. A waterproof underlayment should be installed beneath the shingles. When securely attached, it temporarily protects the building from rain if shingles are torn away by the wind. All nails and staples used to attach the roof sheathing must penetrate the underlying roof trusses, or rafters. Otherwise, the sheathing will not be securely attached and can be more easily torn away by high winds. The issue comes from if you have 2 layers of shingles, you need to pay special attention if you have a house that has been re-roofed where you have maximum of 2 layers of shingles. The nails that are used to attach the nails to the shingles to the roof actually must be longer because the thickness of the shingles is not generally taken into consideration when 2 layers of shingles are installed. Hopefully that makes sense. So when you're in an attic, try to, if you can, pay special attention to making sure that the nails are penetrating all the way through the decking, which oftentimes, if it's a re-roof, you might be seeing the original nails. So all of this is kind of hard. If you do end up being able to lift part of the shingles without doing damage to the shingle in any way, you might be able to tell if the nails are not long enough because the shingles will easily come up. That's about as much as you can do in that situation. All right. So a couple of things here. What time do we got? Perfect. All right. So here's a couple of pictures I took on the left-hand side. So when we were talking about garage fire rated walls. So both of these are new construction. This is actually the same picture. One is looking down at the platform beneath the tanked water heater, and one is looking, or I'm sorry, the tankless water heater, and one is looking up at the ceiling. So in this instance, you have this platform on the left-hand side. So the platform, if you've ever been into a home while it's been under construction, almost every time the platform for where the water heater is going to be, see, the builder, sometimes they don't know if they're going to be using a tanked water heater, if they're going to be using a tankless water heater. So the platform is always built, no matter if it's a tanked water heater. Most of the time, the platform is built, and then the water heater is then installed after the fact. So in this instance, they didn't know 100% that they were going to have a tankless until after the construction was done. And so they built the platform first. So when you build the platform first, and then they drywall down to it, the gap on the back side of that drywall, because if there were a 2x4 that were running from the drywall to the platform, then that gap, then that would meet the fire ratings for the garage. But because they don't run a 2x4 around the perimeter of that platform, that is then leaving the interior wall chase exposed, and now you have free access for fire to get into the wall structure. So in these instances, I always recommend the intersection between the platform and the drywall to be mudded and taped, and that would then maintain the fire rating of the garage wall. And then obviously we have the ceiling penetrations for the vent pipes, for the water heater vent pipes. And again, they did not patch or seal or put collars or protect the penetrations into the ceiling. So you are compromising the fire rating in that instance. And then going back to when we were talking about underlayment, um, this is one of the diagrams that I use in my report a lot when I talk about underlayment configuration and the correct layering of underlayment underneath the rake edge, but over the drip edge, and how it should be installed. So those are my so that so those are examples of what I've seen in the field. Now let's see here, what do we got on time? 7:43. Let's take some questions. Let's go up here. Can a code be referenced? I would not reference code in your report. So to kind of get around that, you can say very generic terms like recommend. Okay, so instead of stating code or stating standard, you can simply state, let's just talk about drywall fire rating in a garage. So I'm not going to say the standard is that the drywall thickness be maintained. I'm not going to say that the code requirement states that drywall must be mudded and taped to maintain the same thickness of the drywall. What I would say is it's recommended to maintain the thickness of the drywall by correctly mudding and taping all penetrations, joints, and nail holes to maintain a fire rating. And then that would be my comment. And then if you use a diagram in your report, then let the diagram speak for you as far as what the code or the standard is. So again, almost every comment I have in my reports, I have a diagram that goes with it. Because for me, in my reports, I don't call out anything that is not verifiable by either code or a standard. And if there's a code or a standard, 90% of the time there's going to be a diagram that goes along with it. So I have five diagram libraries from various producers, CodeCheck, InterNACHI, I can't think of them off the top. Carson Dunlop. There's a there's a lot of them out there. Fine Home Building is a great one. Um, Also, what's the uh, This Old House is another great one. They have great diagrams, and there's a few other. I think Mr. Handyman has one, and there's one more else I'm missing. But uh, yeah. So anyway, that's my recommendation on it. So. Can we get the webinar text information that was read and not seen on screen? Kristen, that is up to, well, I will say, Kristen, if you, being an InterNACHI member, 90% of the content all of the content that I read is in the online or is in the online course that you can review on the InterNACHI website. So if you go to 25 standards every home inspector should know, you go to the course, into the course on the InterNACHI website, and everything that I read is on there. My personal experiences, my examples, all that type of stuff will not be on there, but you can get the details and the factual information from the I would say not factual information, but I want to say I don't know. You can get the all of the very detailed information from the InterNACHI website. Okay. Nicholas, how soon do we have to take the test after this webinar? I think she said within 24 hours, if I remember, but AJ will be able to answer that better for you. Is the 2018 IRC reference when there has been no change to the updated in the 2024 IRC version? Um, let's see, in the 2018 IRC reference when there has been no. So a lot of these courses, so when these courses are created, the current code standard has been referenced. So some of the newer codes, because every state, it's really difficult to keep up with the international codes and every time they change because it takes so long to create a course that we can't change the course immediately after new national codes are enacted. But every state enacts different codes. So like for me, our state, we're right now using the 2021 IRC. And so, we don't, so there is no reference to the 2024 IRC in mind. So every state is going to be a little different. So, but a lot of times, if there are big changes, we will go into the courses and make those changes. But, there's always, timing and manpower and all that kind of stuff. So we do the best that we can, and we get things updated when we can. But the courses are constantly being reviewed and updated. But there are so many courses that it's hard to do them all whenever things change. So keep that in mind. All right. So I do have, if we have a few more minutes. Okay, so we do have a few more minutes. We got 12 minutes. So I'm going to change my screen to some real life examples. Let's see if this will. Oh, here, let me change my screen again. I don't think that worked. Let's do screen two, share. Perfect. All right, so here's a good example. If I can zoom in on this, hopefully you guys can see this. So Missouri is a state that has no state code requirements, and so basically, if you live outside of the city limits of a city, every city will dictate what codes they follow in the state of Missouri. I'm sure there are other states that are the same way, but Missouri is the closest state to me that where you can see this. So in Missouri, there are no code requirements. There is no contractor licensing either in Missouri. And so every city, you have to get your own contractor's license. Every AHJ, you have to get a contractor's license if they require them. And then every city will dictate what code they follow. So if you're in the country in Missouri, it is a free-for-all. So this is an example of what I found on a foundation in a house in Missouri when I did an inspection there. None of the foundation walls that were CMU were filled with concrete, and there was no foundation anchorage, zero. And so basically a strong wind could move this house off its foundation. So this is example one of things that you might find in the field. Obviously, so like I said, most of the time, modifications to your floor structure, to your joists, to your beams is going to be done because of plumbing issues. You can see here where the joist was modified because the toilet was moved over, and obviously you can kind of see where the joist is actually being pitched down because of the weight of the structure above it. So this is very common, and this is in a licensed state, although this is an older home. Here's another example where they completely cut the joist out. So these are all pictures I personally took in my market. Um, Here's another great example. We didn't really talk about open electrical splice boxes, but this is a very common issue that we find in homes where open electrical splice boxes are not covered. I'll share a quick story with you. The I did a house inspection in like a downtown area with an older house. So up in the attic, it had rock wool insulation, and there was lots of modifications had been done over the years, and where the splice boxes were all open in the attic. So I called it out. I put it in my report, and recommended. And there's a lot of issues with this. There's a low voltage wire actually going up into the splice box too. But anyway, um, so about 3 months after I did the inspection, so I did everything in the report like I was supposed to. 3 months after, I get a call from the homeowner. She said, "Hey, I had a house fire. Turns out I should have had the electrical boxes covered because turns out every homeowner that moves into a home is going to use the house differently than the person selling the home. So what might have not been an issue for the seller might become an issue for a buyer because they're using the home differently than how the previous owner used it. So there was open splice box in the attic. She ended up using one part of the house a lot more than the previous owner did, which when they used electrical a lot, you have an open splice box. It got packed with insulation, with rock wool insulation. When she used the electrical circuit that was associated with that splice box, it actually ended up overheating, and that's where the fire started. That's why you have to have splice boxes with protected covers, is because with the insulation gets in there, it contains the heat. So any electrical current carries heat with it. And so much heat built up that it started a fire inside that part of her house. So she didn't blame me, but she did ask me to come out while the house was opened up. We found a bunch of other things that they had modified before they put the house together. There's another example of cutting a joist, and you can actually see where the joist is actually starting to split because the amount of weight that is being concentrated in that area. Um, Here is, you know, this is a electrical connection to a garage, which this garage was probably weeks away from burning down before we found this. So this was a huge safety hazard, very scary, and many, many problems there. So this is a typical crawl space in my area. We have a very old downtown areas, and so I can't, I'm sure everybody in this on this webinar can point out all the damage and all the defects that are associated with this observation. But this is very common in my area. We have, like I said, we have very old downtowns. We have very old homes, and we didn't have any standards before 1998 in our area. So basically anything was a go. So there's lots of things going on here. Again, this is an area. Here's a bell trap that you'll see installed. And you can see lots of things going on in here too. The joist was modified because of the bathtub that was there. And obviously you can see that PEX is now installed. So even though they installed a plumber or somebody installed PEX going up into the water, up into the service for this bathtub, they did not remove the drain and the bell trap on the drain line of the galvanized drain pipe. So obviously we called that out as recommending for upgrade, especially since a plumber was already in that area. And this is an example very common of a deteriorated vent boot on the roof. As we were talking about the distance for DWV vents coming out of the roof. When you're looking at those, the height differences, make sure you're checking the the rubber boot around the vent pipes. And then here's a good example, and I just like to point this picture out. So this is a newer home, was built within the last 20 years. So I just, as inspectors, if it's difficult for you to get to, it's difficult for the contractor to get to, even though in this instance it shouldn't have been difficult for the contractor to get to. This was simply forgotten about. So this is on the front of the home. So this is a two-story house that has a dormer on the front. So directly to your right is the entrance to the home. The only way that I got this picture is I put my ladder up on the gutter facing to the left, and I put my hand and my camera around the edge because I could not get up there because the roof pitch was too steep. And I just put my camera around the edge of the corner and I took that picture just for my own due diligence. And when I took the camera back and I looked at the picture, I said, "Holy smokes!" They completely forgot to side this side of the dormer, and it had been like that for about 20 years. Here's one where the plumber modified the roof joist, or the roof joist, or the roof rafter. Sorry. Obviously, this is outside of standards and was called out as needing upgrade and correction. And that's the end of my example pictures. All right.